monolithic architecture that sometimes are hard to break or improve, especially in the modern technologies or cloud age that we have. And then if you compare it to the cloud age today, there is an opportunity for us to pay less by paying only for the instances that we use, the services that we use. And because of cloud computing and the modern technologies that we have today, it allows us to uh, create this environment or community or an opportunity to learn together and create a learning environment for, like, for example, learning a new technology like
Um,
cloud computing,
uh,
like screenshots
Hi, Jonah.
yes.
I guess there was an unfortunately there was an issue, and we seems like that we just went live now. I guess we need to
Ha.
kind of it's better that we start everything from
Okay.
your session from beginning. Sorry for the issue.
All right, so I'll start again. Should we?
Yes,
Let's see.
thank you.
Let's see. Let me see. Go back. Go back. Go back. I understand. No problem. Let me see. All right. I hope we're live now. Okay. Yes, I think so. All right. Okay. So I'll repeat. I will start from the beginning again. It's good. All right. So, hi everyone. This is Jonah Anderson, and today we will be sharing about, or we will be learning together about infrastructure as a code using Terraform on Azure, and with focus on implementing managed identities in Azure functions as an example. So earlier, Sherry have introduced me, but in case it wasn't recorded, I would like to introduce myself. So I'm Jonah Anderson. I am based in Sweden, and I am pretty diverse in what I do in my job and on the community. And as you can see, I do development full stack in .NET. I also work as a cloud infrastructure and DevOps engineer in my consulting job. On my free time, I use it to inspire tech to others as a community leader of Azure User Group Sweden. And I'm also writing my first book project with O'Reilly, which is They're Learning Microsoft Azure. And I'm also a Microsoft certified trainer and Microsoft MVP for Azure technology. And I like to make my presentations more inclusive for everyone and diverse, so everyone, like beginners, can also get started. So today I will be sharing with you about different topics areas like infrastructure as a code, Azure functions, Terraform in Azure, and also manage identities for setting up the identity for your Azure resources or services. And we will start with infrastructure as a code. So you can think of this box full of golden knowledge in one session from Virtual Azure Community Day, where you learn a lot of different technologies in cloud native development. And we will start first with infrastructure as a code because we need to understand it first, right, before we can start developing. So I'm a person who loves to spend quiet time with books. So on my free time, I either read technical books or books that will help me improve as a person or my career or my job. And one of the books that I've been reading lately, especially during my holidays, is this book by Keith Morris entitled Infrastructure as a Code Dynamic Systems for the Cloud Age. And if you notice here to the left, there's a table here. And this table was one of the tables that I really stopped for a moment and did the comparison left and right. And and I want to share it in this session because it really reflects how it is today in the span of time from the good the good old days and the modern days that we have today. For example, when you're building an IT system in the old age or the iron age, it's going to cost us a lot to build an IT infrastructure because you have to have a data center, you would have to hire people that will maintain it, you would have to find for best software engineers to build that application or system. You would have like servers for database, servers for that and this. And there's there's a big gap in terms of architecture as well. For example, in the old days, you would have the monolithic architecture, and then in today's cloud age, we are using the microservices, event driven architecture, and we have this speed of delivery. And everyone in the team gets this opportunity to learn modern languages and technologies in one project. So, just like the session, you get to learn something about managed identities in Azure functions, but you need to have a background of Azure. You need to learn infrastructure as a code. You need to learn what does managed identities really do for your Azure resources. So, this is a good introduction about what I'm going to talk today, which is infrastructure as a code as well. So, in this book, the book defines infrastructure as a code as a cloud age approach to managing system that embraces continuous change for high reliability and quality. And this is a good quote from the book because I personally believe is that's what I see as a developer, as a cloud infrastructure engineer in all the projects that I've been into, and even the colleagues that have been working on in cloud native projects. So even those old applications that we have today, they're striving to have a system that's durable, highly available when something happens, high quality, that the code, for example, is written well so you don't get a lot of bugs. So infrastructure as a code, it helps in the modern systems that we have today. But what is really the real definition of infrastructure as a code? So, infrastructure as a code actually is that you're managing your infrastructure to build your resources, like for example in Azure, and also to configure it in a consistent way, in a way that is secured, in a way that you can repeat the process and you don't have to do it again or do it manually all the time. And this actually supports this purpose of high reliability and quality because if, for example, if you want to build an infrastructure or system that you can change without too much manual effort, then you can just change the configuration by code and redeploy it and even reuse those infrastructure again if a business use case comes, like for example maybe we need to add Azure resources or maybe we need to do multi-cloud approach and deploy it to another cloud provider. And this is exactly the definition of Terraform on this specific code. So benefits of infrastructure as a code. So as mentioned, there will be the benefits is process automation. You can have repeatable deployments, which means that you can have parallel deployments, like deploy your infrastructure by code in different environments, dev, QA, or even to other cloud providers, private or public clouds, or even third party applications or platforms. And then it's easier to scale in and out, configure or make any changes when needed because you have everything in the code. You just need, for example, one example of this is that you can just, if you have everything set up, infrastructure set up correctly in your infrastructure, by code, then you can just like, for example, you want to upgrade your app service plan to a premium tier, like for example, P3V3. You can just literally just spend a minute changing that configuration by code, and then run and apply your changes, and then the entire infrastructure is up. No need to do a lot of extra stuff just to upgrade an app service, for example, or an app service plan. And you can also enforce compliance and security best practices. So sometimes when you do things manually, in Azure, for example, if you do it manually and not automated, or not in automated process, usually sometimes there are rules or compliance that might be missed, especially if uh, your global administrator or your owner or the one that are responsible for the policy and the governance have missed this kind of compliance and security best practices. And I myself is using infrastructure as code in my job, what I do every day. And I notice as a cloud infrastructure engineer, a DevOps engineer, aside from coding infrastructure by Terraform, because we use multi-cloud approach, I also get the chance to collaborate with different teams, the developers, and even our like DevOps teams and architect, which is I think is a pretty great opportunity for learning and also getting feedback uh, between each other. And of course, infrastructure as a code give us the opportunity to fix or to solve problems with the complexity that we have in architecture sometimes. So maybe one day you have this monolithic architecture, like maybe 10, 20 years ago, but today in the modern cloud age that we have, like business requirements change. People want to be on the top in the market, and when people are using the systems, they also expect to have that system get adapted to the needs in the real world. And this is when our cloud applications and even our architectures can get can get complex. I mean, it gets more complex. It's just like building a building where you're building a lot of windows, and then it gets too complex. And then microservices, infrastructure as a code, and other modern tools that we have, containers like serverless, allow us to have this flexibility. So tools that we have for infrastructure as a code. My topic today is focused on Azure, since that's what my key skills for this technology. But just to be transparent and open to everyone, what are the tools that are available? There is actually many. So to those that are working with infrastructure as a code for Azure, there's the ARM, Azure Resource Manager. There's the Bicep language, and then Terraform, which I will be sharing a bit more today. And then there's also Puppet, Pulumi. There's the Google version, Google as well for it's called Google Cloud Deployment Manager, and also Ansible. I haven't worked a lot with the other parties, but it's good to learn if you're working with multi-cloud approach. So Terraform and Azure. So we did talk about infrastructure as a code. Now let's learn Terraform, which is one of the infrastructure tools that we learned today. So what is Terraform? So Terraform is a HashiCorp product. So it's called HashiCorp. So it should have HashiCorp beside it. It is an open source infrastructure as code tool that is used for provisioning and managing cloud infrastructure and automate the infrastructure. You can also configure or do infrastructure as code for the configuration of your infrastructure. And then it has the multi-cloud support, like if you want to deploy your resources to a public cloud or private cloud or even other third-party services, you can do that by using the Terraform providers. And then on Azure, it is actually used and widely used, especially there's an example in here. First, of course, it's used for infrastructure management, but there it has been known as well that Terraform has been used to create a blueprint. So there's an example of a GitHub repo here where they have used Terraform for making blueprints through the cloud adoption framework. And then, of course, you can provision DevOps pipelines and automate your application deployments and infrastructure using Terraform and provision with that as well. So if you're coding Terraform, this is one of the basic thing that you need to know at least. So typically there's like what we call a Terraform workflow. So you write your infrastructure as a code using your favorite editor. For my case, I use VS Code to code Terraform, but you can use any supported tool or IDE that you want. So you write the code, you author the infrastructure that you want to build. Of course, you need to know what you want to build, of course. Write it, and then when you're done writing it, you're going to have this plan. Usually, you write the six syntax Terraform plan, and in the plan, you'll be able to see the overview of what resources are going to be added, what resources will be updated, which resources will be deleted, for example, if you're doing some deletion. So this is one of the top or one of the known good features of Terraform. That's why many are considering using it for the multi-cloud infrastructure as code approach. It's because of that feature as well that you can preview your changes in the code or your infrastructure before you deploy or apply it. And then when you do the apply part, which is the third step, that's when you do the syntax Terraform apply in the Terraform CLI. And then that would provision your infrastructure to your selected providers. For this case, it's Azure, for example, and they usually have Azure RM provider for this. So this is the AS infrastructure as a code perspective, the workflow. So you have you, the coder. It can be a developer or infrastructure engineer, DevOps engineer, writing the code, infrastructure as a code, and then you're gonna do the plan, make sure all looks good, and then you might wonder, what if the plan doesn't look good? What would I do? So that means you need to go back as a developer, infrastructure engineer, go back to your code and make sure what went wrong there. If your plan is saying that it's gonna destroy an Azure SQL database that has lots of data already or tables in production, then maybe when you see that plan, you need to back off and think, did I do something wrong in my infrastructure as code? So it's like coding, for example, you do some debugging. If something turns red, you cannot build it, then something is wrong with your code. You have to go back, see the plan again, and then apply. And before you can actually start doing plan, you also have to do the Terraform init command. That's to initialize that you have all the modules you need for your selected providers in Terraform. So here you see that you can deploy. Once all looks good in the plan, you're satisfied with the resources that you want to deploy or recreate or repeat deploy to your cloud provider. You can apply it to your to any cloud. So you can deploy to Azure, to GCP, to Kubernetes, AWS, and other providers that support it. And I know that HashiCorp Terraform has a lot of that. So that was Terraform on Azure. So let's go to Azure Functions, which is one of the topics that I talk a lot for the past year, especially during the pandemic. So, uh, but I'm not going to deep dive in that today. So, Azure Functions is actually a serverless compute solution in Azure, and it allows us to write less code and be effective as developers, which means that as a developer, you're gonna write the logic to your code, what you want to do, and then it's you would need to have some kind of event. So since it's event driven, and for event driven architecture, you kind of have something to happen before your code gets triggered. So in this case, you can have, for example, you have an Azure Cosmos DB, a database that you want to, for example, do something, another activity like process an order after you receive a data in a database, for example. So you can use the Cosmos DB trigger to trigger your event or your logic. Your code runs, and then you pass in the data that you need, input and output, and then process it further with different activities that does different work with other Azure resources. So the key highlight of Azure Functions is that you maintain less infrastructure for this one, which means that you don't need to worry about the underlying infrastructure behind Azure Functions, and you can easily get started delivering what you need to do using this serverless compute service. And one of the extension of Azure Functions is Azure Durable Functions, which is also a powerful extension that allows us to write stateful workflows or orchestration of events by code. Because I know that you can also create stateful workflows using Azure Logic Apps, but that Azure Logic App is typically used for low code, no code solution, which is also very good in terms of integrating or creating workflows with other Azure services or SaaS services or platforms. So that's Azure Functions. And now we're going to deep dive into managed identities. So before we do that, I want to share with you the common problems or scenarios that I have personally experienced or have noticed as a developer for the past years, and even as a cloud infrastructure engineer working with these technologies that I'm talking about. So specifically to the fourth topic, which is managed identities, I noticed that why is it like why is the reason why I'm showing you this common problems or scenario is to show you why managed identities are even used. So one common scenario is that sometimes in some projects, including in my own projects that I have or have been to, developers are using their own uh, personal access tokens or even their own credentials, for example, in Bitbucket or GitHub, their own account, to access and develop or manage resources in Azure for a company account or an enterprise app account. So that is something that many administrators or cloud administrators might have missed. Of course, developers can use their own personal tokens if needed for own development, but when it comes to putting it to develop to higher environments, it will be a problem. It will be a problem because for example, a developer is just a consultant in that company, and that consultant maybe is just short-term consultant, 3 months. And then maybe the developer is very good developer, delivering everything he or she can, but then he or she forgot to say to the administrator that, hey, I used my path token to access our Azure DevOps pipelines or access this app service. So in the app registration or whatever that was set up. So this is a common scenario that ends up that the DevOps or the people members, the team members in the team are gonna go in panic mode, and they don't know how they would resolve it. Of course, they can solve it by just getting a new tokens, but there should be a common way specific to the service, I mean, to the application to generate this kind of access tokens or secrets. The second scenario that I also learned or noticed is I work with release management in my job. So basically, if there's a new application, .NET application that needs to be deployed to Azure, first, I build the infrastructure by Terraform. I code it that way. And then once the infrastructure is built in the first environment, which is dev, then I can set up the pipelines. I need to set up a new pipeline, for example, Jonah's new function app that will do great great things. So I set up the pipelines, and then in order to set up the pipelines in Azure DevOps, I would need to create a service connection between Azure DevOps to, for example, my GitHub, or at work, for example, we're using Bitbucket Cloud. So I would need a service connection, and in order to create a service connection, connection to deploy. I'm mixing up things now. I'm talking about release pipeline, by the way. To create a release pipeline to Azure, to deploy things to Azure, you would need service connections. And in order to connect or get service connection, you would need service principals from Azure AD. And usually, you would need to have Azure AD tokens or secrets to put in your service connection in Azure DevOps in order to create that release pipeline to Azure. And by security default or standard, Microsoft recommends that the token expires at least 6 months or max 6 months, and then it needs to be renewed. And if you are a DevOps engineer, cloud infrastructure, like taking care of this service connection or an Azure admin, you would have to keep track. For example, Jonah created this new pipeline with new service connection, and in 6 months that will expire. But there's a problem here. Jonah was responsible for this token. He or she can save it on the key vault, but Jonah needs to keep track of this token for before 6 months. Otherwise, the release pipeline will be broken, and whatever needs to be delivered in production, that will be broken as well. So here you see the second scenario of the problem about connection. Having this manual process of changing tokens every 6 months or the expiration. The third one that I also noticed is that managed identities needs to be when we do integration, like for example with Azure DevOps, just like the previous example, and other APIs or third-party resources, you would need to have some kind of token or identity object from Azure AD to allow you to read those resources as well. And then another scenario that I also notice, this is real life things that I am putting here that I do, almost small things that I do every day. I mean, not every day, but all the time, is that sometimes if a new application gets developed, of course, the connection strings cannot be hard coded in the code. That's a security best practice. It's the best solution to put it in the key vault and update it, and then the key vault can be read from your code, application code, or your infrastructure code. But if you are an Azure administrator, it is actually an extra hassle or manual job for you to put in those keys, update or delete it, especially if it's a client secret that's related to service connections or service principals outside Azure or third-party apps. I recommend using Azure Key Vault for like connection strings and other related app settings. But in terms of third-party ones like service principals and integration, it might be a bit of hassle, especially if it needs to be renewed and generated. So before we go through the different like types. So there are like you need to understand the concepts of Azure AD. So Azure Active Directory is like it has this different types of identity objects and different permissions. So the types of objects that we have commonly is that we have Azure AD users. So I can be part of an organization slash tenant and I'm counted as an Azure AD user. I have my own identity and properties. You can have an identity object of a group and even the application itself, which is also called enterprise apps in Azure AD, has their own kind of object. And then permissions, if you have worked with Azure AD, there's this rollback access control. There are predefined roles, lots of them to choose from, depending on which Azure resource that you're working on. Management groups, there are many of them as well, and etc. There's a lot. So, but the reason why I'm sharing about an intro about Azure AD object, identity object, it's because it introduces us to service principles. So, service principles actually serves as identity objects for applications or any apps or entity that is not counted as an Azure AD user or group. And the typical uses for service principles are actually to create, like the examples or scenarios that I shared earlier, is to create like service connections for your application or deployment pipelines. If you want to integrate with other Azure services or third-party ones as well, I have an example of this from work. So we're implementing a third party code scanning tool in our pipelines. And since it's out non-Azure tool, we have to kind of like to set up to allow that code scanning application, I mean, tool into our infrastructure or DevOps pipeline. So these are also the typical use why you would need to use service principles. And of course, infrastructure as code. So if you're using like your infrastructure as code using Terraform, you would also typically need to use service principles for that or manage identities. So manage identities, it was previously called, if you can find it in other Microsoft docs, it has this short name MSI and it's the short name of Microsoft Service Identity, if I remember it correctly. Yes, but Microsoft Docs, based on Microsoft Docs, what is it? So managed identities provide an automatically managed identity in Azure directory for applications that will allow them to connect to resources and it support the Azure AD authentication, specifically the RBAC role-based access control. So it allows you to obtain tokens without having to have these credentials. And usually you see this example here. This is from Microsoft Learn Docs. You see that we have this media service account that has a managed identity and is used to access another Azure service, which is the storage account. And then here we have another example of a managed identity used by a media service account, and it's also used to access the Azure Key Vault. And then we also have Azure Functions that uses managed identity, and it's used to access another service, so vice versa. So uh, this is the reason why managed identities are very useful in terms of communicating and integrating different apps within Azure, even other integrations like in DevOps, for example. And one thing to know about managed identities is that it has different types. So when you're just getting started, one of the questions that is typically asked, should I use system assigned or should I use user assigned? So that's a good question, right? That's the first question I actually asked when I was new to managed identities, which is I'm still actually deciding with my team at work. Are we going to use system assigned for this Azure resource or are we going to use user assigned? And then you have to stop and think, uh, we should use system assign if we're going to do this and that, and user assign because this application is going to talk to this resource, that resource, this resource, and there. So you get the point, the difference. So system assigned, it is actually associated with an Azure resource itself. So for example, an Azure VM or an app service, if you assign it to, if you set the identity to system assigned, then it is associated or linked to that resource itself, that VM. So VM called VM Jonah. So that is system assigned. And when I delete that virtual machine or app service, that identity is dead or deleted along with that resource. In comparison or in contrary, we also have the user assigned. So user assigned managed identity is that it's like an object itself. It's an identity object itself that you can configure or set as an identity to multiple Azure resources. So it can access multiple ones. And this is perfect if you have an app or an API that needs to talk to many resources within the infrastructure. All right, and let's see here. And then this is an example. So we have a good example here of managed identity. This is actually a graphics that I did this morning. So we have managed identity, user assigned. So let's just say I have called my user identity MI, number one. So Mission Impossible 1. Just kidding. So MI1, user assigned identity, is gonna be used. Oh, that should be M1. Actually, it's gonna be used as same identity for each of this virtual machines. So this one is an error. It should be M1, M1, M1. And if you're gonna use system assigned, so you would have to create one system assigned identity for each of the VM. But the point here is that user assigned, you can use the same identity per Azure VM. And if you're going to use system assigned, you would need to have specific identity for each of this Azure resource. So, managed identities, not all Azure services are supported. So, but there are services that automatically manage the identity in Azure directory. So if you want to learn the list, you may scan the QR the QR code. So I'm gonna do a demo, so which means that I'm gonna maybe not switch screen, maybe to make it easier for Sherry and Morton. I hope you see. Let me just put the code over this one. So um, first, I'm gonna show you the manual way of. So here in Azure. By the way, I'm using this tool, a plugin called Azure Moss. So let me just clean up a bit of my bookmarks so you don't see my secret bookmarks. Just kidding. All right, so I have this tool called Azure Moss that allows me to hide some subscription ID, for example. So I'm gonna do two parts demo. So first demo is that how would you do it in Azure Portal if you can't do a Terraform? It's easy. You can do it in the Azure portal. So let's just say I have this resource group function infrastructure as a code demo, and in here I have a resource which is an Azure Functions. It's running. There's no code in it, but I know it's running, and it's starting. And if I want to, for example, implement system assigned, which I already turned on, you can just go to the settings menu, go to identity, select system assigned. By default, it's off, so you can turn it on. You're gonna be asked to add a role assignment for that, so you can choose between breather, contributor, and whatever necessary permissions that you need for the system assigned for this app. And you can also use user assigned. This is different because in user assigned managed identity, you would need to like choose one, for example, that one, and then you're gonna add that to your function app. And then when it's done, I can use that identity to for my function app, this one. But later on, maybe I decide to use this identity on my Azure Cosmos DB for the same project because they need to access or talk to each other through that identity. I can also do that. So that's an example on the Azure portal, the manual way. So you can just go directly and turn it on and turn it off. And then Terraform code. So if you already got started with Terraform, I want to show you quite a bit, not not long since maybe we have limited time soon, um, how you would do it in Terraform. So basically in Terraform, there are uh, top or a few files that you need. For example, you would need the main file. It's like if you're a C# developer, it's like the program.cs in a console app. Like we have everything, and then there's the providers file where you put in your required providers. In my case, I am using Azure RM, which is for Azure because I want to deploy to Azure Cloud. And then I have my variables file, my local files that I can choose to work locally and then not commit it to my source control. And then in here, I have created a module. And in my module, I can actually have like my own Terraform code for per resource. For example, here I'm declaring that I'm going to create an app service plan with that name, what resource group, the location, which is I'm gonna configure in Sweden Central, and then there's also the app insights, and then the outputs, resource group, and other things that I need, the storage account, and here is the function app. So here is an example of creating a resource for Windows function app. So by default, this is a syntax how to create it for Windows. If you're going to create Linux, you would need to use another syntax. I think you changed the Windows to Linux. And then this is my variable name, you can call it if it's programming. And then the name, and then the resource group, the location, the settings that I want. For example, for the function workers runtime, I'm using .NET. But if you're familiar with, I mean, if you're creating an Azure function for other language like Node.js, Java, or PowerShell, you can actually just change that settings here. And in the app instrumentation key, you add your key for your app insights. So without going through in details each of the code, what I want to show you is how it is declared in the main.tf file. So usually example one is how you would do the system assigned. So for system assigned, you would, so first I would have the modules as my like source for that. So I've created that, and it is actually enabled in the app itself. So if you go to the Windows function, I did set my configuration to system assigned and then have my roles in there. But you can also, like, it's not actually a clean code, to be honest. I need to clean this up before I commit and share with you. But another example here is in line 15, you have a user assigned example in which I'm creating another module, which is this one. It has its own like little infrastructure itself. And then instead of using the identity type system assigned, I'm putting in a user assigned. And then in another parameter that I want to have is the resource IDs of my uh, assigned identity. And this is actually, that ID is actually coming from here. So I created my own identity, just like what we did earlier in the Azure portal. We created one, and then we assigned it to the function app. By code, infrastructure as code, in line 23, I created a user assigned identity called this one, line 25, and then put it in the same resource group, and I'm implementing it in my function app that's dedicated for to use user assigned. And my role definition is contributor, and I'm also linking that role into the identity, which is used by my function app. So that's my demo. Unfortunately, I cannot do Terraform apply and stuff because early this morning, when I woke up, I was having networking issues with my IP address on the Terraform state management. I didn't want my storage to be open to public. I used a private IP, and then it got a bit messed up on the networking side. So I cannot apply it, but it worked. It worked in my machine. All right, so that was my demo. If you want to learn more about Terraform and Azure, here are the Microsoft Learning links for you. You can just scan it. I will provide a copy of the presentation later to the organizers, or you can reach out to me. You can also learn about Bicep, Azure Functions, and serverless learning path, and also identity with Azure. That includes the one that I also shared as well. So thank you so much. I apologize there was an interruption there for the recording, but I hope that you were able to catch up and learn something from me today. Reach out to me by scanning the QR code. It will direct you to all of my social media. And thank you from me. And this is my dog, Lawrence, saying hey. Thank you so much.
All right. Thank you, Jonah.
Yes, thank you so much. Any questions from everyone?
Uh, no, still no questions in the chat, unfortunately.
Yeah,
Yes.
all right. Yes,
So if you
okay.
have any questions for Jonah, as you mentioned, reach out to her. I'm pretty sure she's very fast in answer. So and thank you for that, Jonah.
Yes,
Yeah, and then we can maybe go on since we are behind the schedule.
yes.
We can actually go on for the next speaker. Thank you, Jonah and Lauren.
Thank
Most
you
of
so
you
much.
for coming here. Yeah.
Thank you.
So we'll say
Bye.
goodbye and
Bye.
immediately hello.
Yes.
Goodbye,
Yes,
Jonah.
thank you.
I'll just
Bye.
say that I also love Terraform. I use it quite a lot.
Yes, that's great. That's great. That's great. Yeah. Talk to me or reach out to me to those that has a late minute question or if you watch the recording and enjoy the next sessions coming for the rest of the day.
Yeah.
Bye
Thank
bye.
you.
Yeah.
Bye.
Thank
Bye.
you very much. Okay. So
And
I guess this
welcome,
is
Eric.
yes.
Oh, was I too quick? You needed to do the introduction, Sherry.
Yeah. So thank you, Eric, for joining us. So our second speaker is here, of course. He is a principal consultant at Delegate. His manager. He manages a number of open source data access tools and libraries, including SQLite Toolbox and EF Core Power Tools for Visual Studio. Thank you actually for doing that, Eric. So we all know that storing secrets and passwords is always complicated and risky. So today, Eric is going to show us how you can use Azure SQL database with Azure Services and Azure Active Directory and have a password-free life. So I'm personally very curious to looking at your session. So stage is yours.
Thank you very much. Yes, I had a quick, small look at the previous session, and I think maybe there's a little bit of overlap here, but it's nice to get the message repeated. This is definitely the way you should be doing things going forward, because as I will demonstrate in this session, it's certainly doable for using many services, and even if you have to do a little bit of quirky ways to get around with doing it with SQL Server or as a SQL database, it's possible, and I'm happy to share how it can be done.
Yeah. Do you want to try and share your desktop or slides?
Yes.
We can bring it up.
Oops. There we are.
And during the session, if you have any question for Eric, please feel free to put it in the chat. We are going to bring it to him at the end of his session.
That's cool.
Right.
Yeah, so we'll just start with a little bit of presentation here, and then we will jump straight into the demo. This is about avoiding using passwords when you are connecting, for example, an app service or any compute service to some other service in Azure. You can use a feature called Managed Identity, and we will dive deeper into what that actually is and how it works. In this example, we are connecting like a classical example of connecting an app service to an Azure SQL database. If you have been working with Windows previously, there used to be something called integrated security, and that is to some extent what you're getting here, but in an Azure environment with Azure managed services. Yes, you already mentioned, Sherry. My name is Erik Ejlskov Jensen, and I work for Delegate. And you can reach out to me on GitHub and Twitter. I also have a blog on github.io. And my social handle in all those contexts is Eric EJ. So the topics for today's talk is an overview of managed identity. What is it? What is the purpose of it, and how does it work? We will do a sample deployment, live deployment, while I'm speaking, and I will go you through the steps in order to deploy a web app and a SQL database, as a SQL database, and apply a managed identity to that database connection and see it in action. And we will also have a little bit of a look under the hood to understand more about how does app service knows about the managed identity, and basically how does it work a little bit under the hood. I will show you some ways that you can see that. So what is managed identity? Managed identity is a feature of Azure Active Directory, which when you create a managed identity or a service that has an identity, it will create a service principal. So a service principal is essentially like a user account, but it's just a special user account where you don't need to manage passwords on it. And that is associated with or tied to the Azure service itself. So applications that host those services can then generate tokens using that identity, so you don't need to provide any credentials, and they can use those access tokens, Azure AD Azure tokens, to then authenticate against a number of other Azure services. And I think nowadays most of the native Azure services support managed identity, so you are able to assign an identity to all the compute services and all the for all the storage services and so on. They can understand and authenticate when you come with a managed identity access token, because it's just like any other Azure AD access token essentially. We'll take a deeper look at the token as well when we get into the demo. And why is it secure? Because the applications that host that service will have a managed identity, and only those applications can generate the tokens. So we will also dive into how that token generation works when we get a bit further. So by having this managed identity, you can also manage the lifecycle and permissions of your apps, so to speak. And you can even, like, if you have a rogue app, you can even disable that account and it will no longer be able to access your resources. So this is kind of a schematic, simplified schematic of how does a managed identity work. You have a app service, which is this blue box in the left-hand corner. And you have the service itself, which is running either under Windows or Linux. And that service is then connected with a managed identity. And when the service requests the token, it actually calls a special service running on the same server or the same instance as the app service. And that service will then request a token on behalf of the service from Active Directory. It will receive the token and pass the token on to the service. So now the service will have a JWT token, and then it will use that token for further requests against services like, for example, in our example, Azure SQL database. And when that token is received together with a request, there will be the service that receives the request will be able to verify the token number 6 and against Active Directory to determine whether it's valid and whether it's current and so on. And then once the token is verified, the service can then provide the data that that the app service requests. So there are actually two different types of managed identity. That's system assigned identity. So they are the same as an associated resource. So if you create a system assigned identity and remove the resource, that system assigned identity will never appear again. So when you create an app service and assign a system assigned identity, and then you delete the app service, then the system assigned identity will disappear with that app service. So that also means that the unique ID of that system assigned identity will never appear again. You can also create user assigned identities, and there are like proper Azure resources, a standalone resource, and then you can associate that user assigned identity with multiple services. both compute and actually storage services, as we will see in the sample in the purpose of SQL Server. Why is user-assigned identities useful? Because you are in control and you control the life cycle of the user-assigned identities. Of course, if you, for example, if you use a system-assigned identity and then accidentally delete your app service because it doesn't really hold any data, so you can just recreate it, then you will actually have to. And if you have given that system-assigned identity rights on some other system, then you will have to reapply the rights, because the system-assigned identity that was originally there will be deleted together with the resource. So one way of preventing that, of course, is to use logs, and also for system-assigned identities and also user-assigned identities. Microsoft is working on improving this. For example, by providing some kind of soft delete functionality for managed identities. But it's not currently available, so you have to use other means, like logs is an approach that you can use. So in this demo, I don't know if you can see this, it's a little bit vague, but in this demo, we're going to deploy a website. And when you deploy a website, you also need a hosting plan, because that's like the virtual machine that the website runs on. And we are also using application insights to monitor our website. We will use a user-assigned identity. You can see it's like at the middle of the screen at the bottom. And then there will be a connection string that associates the website with the SQL Server. And the SQL Server will have some firewall rules. It will allow Azure services to access it, and it will also allow my own IP address to access it, so we can actually have a closer look at it. And of course, the logical SQL Server will have a user database as well. You can also secure your. So now in this setup we are avoiding storing passwords anyway. You can see there's no key vault in this infrastructure. You can also make other means to enclose your logical SQL Server in a private network, so that only the website can actually access the SQL Server. But that's not part of this talk. So for the demo, the deployment parts is the goal is to provide a web app with passwordless access to an Azure SQL database. And one of the design goals when I created this demo was I was really striving for a minimal amount of any code, whether that is actually like application code or a code that defines the infrastructure. So for the infrastructure, I didn't choose Terraform, Morten, sorry to say that. I chose Bicep, which is a domain-specific language on top of Azure Resource Manager. So it's Azure specific, but it has really nice tooling and has syntax checking and things like that. But when it's executed, it's actually transpiled into normal, if you want to say that, ARM JSON. But it's a nicer development experience, and it's much more compact format, as we will see soon. And then I made an app also with a minimal amount of code. So I chose a .NET 6 minimal web API, published to an app service web app. And then there's some configuration needed because it's really, you can't just click through on the portal to connect an Azure SQL database and an app service. Also, the configuration steps that I will show you, sometimes you are deploying in an environment where the service account that is doing the deployment, it is often not yourself. It's often like a service account from Azure DevOps or GitHub Actions. And those accounts usually have limited Azure Active Directory rights. meaning that they can't browse users, they can't look up users in Active Directory, even on name. And the script that I have created solves those issues by using a user-signed managed identity together with a little bit of a hack. But let's see in the demo. So let's switch to the demo. Hang in there. There we are. So here we have Microsoft Visual Studio, and I have created a very small app, web app, .NET 6 web app. Is the font okay out there? And I have strived to create a very, very small app here, which does something useful. It's not just hello, Virtual Azure Day. I have added a couple of packages so we can actually log any issues that happen in this app by using application insights. And then I have added a package that I have created that makes it easy to use a SQL server, raw ADO.NET from a .NET Core app. So this part here is actually enabling us to run the app interactively on our own desktop by using a tool called Swagger. I will show you shortly. And then I have created an API endpoint called persons, which will return a nice list of persons in the AdventureWorks database with a nice indentation and listing of the addresses and the customer list from that table. So let's try to run this app, and just so you can get an idea about what it does. I also have a connection string here that simply connects to my local SQL Express instance in this case. So I can run it locally, and that SQL Express instance has the same database installed. So when I press F5 in the app, I will actually get this web interface open for me. And I can try to run the endpoint. And it's spinning. And then I will get back the result, which is this nice list JSON response with a list of customers with some customer information, and then an address object inside it. So that's what the app does. Then I'm going to show you the bicep file, which defines all the resources that we need for this purpose. The resources I showed you on the drawing earlier in the demonstration. So we will create that logical SQL server, and we will make it a Active Directory administrator with Azure Active Directory only authentication, so you can only authenticate to this database using Active Directory authentication. You cannot use a username and a password. And then we will add a database from the basic school. I've also strived to make the demo resources as cheap as possible. And we will also, in that database, we will actually load the AdventureWorks LT schema. So we will get like demo data inside the database when it's created. We will add a firewall rule that allows Azure access to the database. And we will add a firewall rule that allows my IP to access the database. I will show you how I do that in a few minutes. Then we add a managed identity, a user assigned managed identity. I will show you what it looks like in the portal in a minute. But this is a managed identity that this whole talk centers about, and I'm using a user assigned managed identity that has a name and it appears as an individual resource in my resource group. And then we will add application insights monitoring, and we will add a hosting plan. So again, the cheapest possible one. And we will add a website, and you can see I'm setting some identities here for the website. So you can actually have both a system assigned. The possible choices are system assigned, user assigned, or just system assigned and user assigned, or just user assigned. And if you have user assigned, you can actually have multiple identities assigned. You can see this is an array of identities here. So I'm just assigning the identity of the resource we created above as one of them. System assigned, I would recommend that you keep this configuration. If you're using a feature called key vault references from your web app, you need the system assigned identity because that feature in Azure Web App, like key vault references, you can write a special syntax in your app configuration in app service and reference a sequence in the key vault. But that only works if you also have a system assigned identity for the web app. And then we will store the connection string for the application insights in a web app. And we will also add a connection string to a web app that points to the database. Let's try to just break down this connection string a little bit. So let's just make this a bit bigger. So we will have data source. So let's just break down the connection string here a little bit in parts to understand what is going on here. So we will set the data source to point to our logical server. And in a Bicep, we can get the fully qualified domain name from the properties of the SQL Server object. And then the use port 1433. And the initial catalog, of course, will be our database name. It's always highly recommended to have a relatively high connection timeout when you're using Azure SQL database. I have a blog post with more recommendations about how you should act a little bit differently when you're connecting to Azure SQL database. And then one of the magic parts, of course, is telling the SQL Server driver that you are authenticating via Active Directory managed identity. You have encryption set to true. All encryptions to Azure SQL database are encrypted. And then you need the client ID of the MSI. I will show you later what it looks like in the portal to be the user ID in the connection string. I know it's a little bit odd, but that is needed when the app service needs to request a token. It needs to pass the client ID of the managed identity. Otherwise, the service that runs and requests access tokens doesn't know what identity to request the token for, and it will use the system assigned identity instead. So you need to be explicit about which of the user-assigned identities you're using, and you do that by providing the client ID here in the connection string. So I don't know why I'm saving this. I shouldn't be doing this. Undo changes, yes. We pass in some parameters to our bicep file. Our administrator ID is not a password, but it's our object ID, and I have specified that in a parameters file. That is my ID, and then an Active Directory login of the administrator user, my email address, then where the location for the resources are, and what environment name we are using, and that is used to construct the resource names down here. And we also passing the public IP address, which is my IP address. So let's look at the deployment script. All these scripts that I'm showing here, of course, now I'm actually just running them in interactively here on my machine, but they are building blocks for building a pipeline. I just don't want to make it more complex or have too many moving parts for the demo, but you can certainly take all the parts here and move them into tasks in a pipeline, either in Azure DevOps or GitHub. So let's look at the deployment script. I'm setting which environment I'm deploying to. I am using this little trick here to get my own IP address, my external IP address, and then I'm passing that as one of the parameters. You can see up here, public IP. I'm also passing the name of the environment, and then I'm referring to my bicep file as my template file, and my template parameter file is the parameters file. It just contains my my object ID. And I'm just using new Azure Resource Group deployment like you would do with a normal ARM JSON file, but it just accepts a parameter of something that's called bicep at the end, and it will invoke bicep and know how to transpile this into ARM JSON before it actually invokes the deployment command. So let's launch the developer console. Open in terminal. So now I've opened the developer PowerShell in Visual Studio, and I'm going to go to the IAC folder. That is where these files you can see up here. Let's just go in here. This is where these files up here live. And then I'm going to run the deploy script, but let's just verify that I'm not cheating too much. So we can go to our resource group. This is the resource group we will be deploying to, and I will just refresh the portal, and you will not see any resources in that resource group, just to prove that it's an empty resource group. And then I will do deploy. So now I will run the script that you can see on the top of the screen, and it will specify the environment of demo. It will get my IP address, and then it will run the bicep script with those parameters that I just supplied. Oops. I'm just switching to PowerShell Core here, actually. So let's just try one more time. So I'm not running Windows PowerShell, I'm actually running PowerShell Core, because that version of PowerShell on my machine has all the Azure PowerShell commands installed. So while we are doing this, let's go back to the program and have another look. So I'm trying to make a useful program here that doesn't have a lot of additional code. So I'm just using the new JSON features of SQL Server to directly ask SQL Server to generate a JSON document, and then I'm serving that JSON document directly from my endpoint. Also noting that I'm using the SQL data source class, and it allows me to not have to manage connection strings in my individual controller methods. So let's just quickly go to the portal and see if anything's happening here. So you can see it's already now started creating some of the resources that we need. So this will create all the infrastructure, the database server, the web app, our application insights monitoring, and the managed identity that we are going to be using for connecting to the database. All those objects will be created in a resource group, which will act as a container for those resources. Let's see. So now we're just waiting for the database server to be created. So let's see, you can see it's already created the identity object, and I'm using some naming scheme from Microsoft for naming my resources. So you can see the last part of it is app, ID, and plan. Those are actually recommended resource abbreviations from Microsoft. As a page from Microsoft that recommends to use these abbreviations for naming your resources. Let's have a closer look at the managed identity. So you can see the managed identity is an object. You can see there's some overview, some help here to determine what resources is this managed identity associated with. Will help you understand why you shouldn't just be deleting it. So it can actually show you that this one is associated with our web app. But if we go to the overview, we can actually see that there's a client ID and an object ID. And in contrast to system-assigned identities where you are unable to query the client ID and object ID, you cannot query that because you will normally not be able to query that because you have limited Active Directory rights. The client ID and the object ID are direct properties on this object, so you can query them directly. And I will show that in the script how we are doing that. Let's see how the deployment is going. Refresh. Yes. So now we also have a SQL server, so and the database. So let's just look at the configuration of our SQL server as well. So just to show that is how it's configured in terms of Active Directory access only. So you can see here we says support only Azure Directory authentication for the server, and I have made myself admin. You can also make a security group admin, so you can enter your database administrators. But usually when you do that, it's also recommended to make your service account part of that administrator group, so your pipeline service account can manage the database for you. So now we have all our resources deployed, just waiting for something to run on them. And the next step is to actually build and deploy our small web app. So the next step phase to do that is to run our publish script. And again, this could be easily run in a CI/CD pipeline. I'm just running it on my machine for convenience, or to lower the bar of understanding, so to speak. So what we're doing here is, again, we're setting the environment. We are publishing our app with .NET Publish, which will basically build the app and prepare it for being deployed. And the content of that will be put into a publish folder. And then we will zip everything that's in this publish folder into a zip file. And then I will get a reference to our web app. We'll get AC web app and specify the name of the resource group and the name of the web app. And then I will publish the zip file to that web app that I got a reference to earlier here. So you can see the same reference down here. And I will point to the zip file, and I will be able to do it again and again by specifying force. So let's try to run this. So we are now building. Publish. So we're now building the app and creating a zip file from the output of the build and publishing that to our app service. So now it's building the app, it's creating the zip file, and then it's publishing the app to publishing the zip file to our web app. And very soon we should be able to run the app once it's published. So we can go back to the portal in a few seconds and do that. Yes. So let's go back to the resource group and have a look at the app, the web app. So it's configured with an identity down here. It has a system assigned identity because we had that on. And then it also has the user assigned identity. And again, we could see that also from the perspective of the user assigned identity, we could see that it was associated with this app. So it's able to act using this identity once you specify that you want to do that. So let's try to go to the overview and run the app. A new window. And I'm getting HTTP 404 because I'm actually requesting something in the root of the app, and there is no default HTML file published in the app. The endpoint is actually called persons, as you saw earlier in our Swagger demo. So let's try to run this. Let's hang on 1 second. I want to show you something else on the app. I want to show you the configuration of the app. I also showed you that in Bicep, but I just want to show you the result of that. So we have a connection string to our application insights resource, but we also have a connection string, which is the one I showed you earlier in Notepad, which connects to our database and database server and has Active Directory managed identity set in the connection string. I don't know if you can see this here. And then it has a client ID. This is a client ID of our managed identity. So it will use that for requesting an access token when connecting to the database. So now I'm just trying to call the person's endpoint. Just double check whether that was actually the name of the person's endpoint, as you can see here. And it's running. Oh, now we got an error, HTTP error 500, so the app crashed. So let's just try to go to the web app and try to figure out what went wrong. So maybe it's crashed so early that Applications Insights didn't even catch the error. Maybe not, but let's just try to do some troubleshooting just with some of the tools that is part of App Service. So if you go to the advanced tools, and what the troubleshooting I'm showing here does not require you to enable any special logging or anything. It's all default logging. That's part of how a web app works, that you can add additional logging if you want to configure it. So let's go to the debug console, and which will allow us to browse this file system where the web app is actually running. And if we go look in the log files folder, there's a file called event.log.xml, which we can have a look at. And you can see there's some error happening here. I don't know if you can see it. Let's just zoom in a bit, if I can do that. I can. So the error here is login failed for user token identified principal. So that actually means that we are running our code. We can see we have reference here to our own code down here. But when the SQL client is trying to connect, it's saying that I don't know who this user is, so I'm not letting it in. So login failed for that user. So the last part of gluing all this together is allowing the managed identity access inside the user database. Let's see how we can do that. So the third script is actually, the configure script is a PowerShell script again that again refers to the environment and determines the names of the resources based on the environment and the naming standard. And then we have this converted to SID function. SID means security ID. It's kind of Windows concept, and that kind of reflects the fact that SQL Server was originally designed for Windows. So when Windows is storing unique IDs of users, is actually when SQL Server is storing unique IDs of users, is actually storing them as in a SID format. So this method takes a GUID and converts it to SID format. So here in this script, we are getting the ID and the name and the access token of the managed of the current identity. In this case, it will be my identity, but it could also be our pipeline identity. So I will get a token here. And also notice, I didn't show this, but let's just go back to this. Also notice that the SQL Server firewall, if I can find it, down there, the firewall of the SQL Server, which we can find under networking, I believe, has been so my IP address has been added in the script, which will allow me to connect to the server. If I did not do this, I would not be able to connect to the database server. So you need to add the IP of the agent running the job, running your pipeline, also as a firewall rule, and then maybe delete it afterwards. There are some specialized tasks in Azure DevOps, I know, that can do this for you automatically. So it will add a rule, and then it will automatically remove it when the task has been completed or failed, for that matter. So we are trying to figure out what went wrong. We know what went wrong, and now we are trying to fix it. So I will get a SQL token, and we will just push it out to the console. And then we can actually use a module called AZ Managed Service Identity to get the to get the user-assigned identity properties. So this will get the client ID and the user ID of the user-assigned identity, and we can refer to the client ID here. And I will also. So now we have the client ID of our user-assigned identity. If your service account is able to browse Azure Active Directory, you simply need to, you can just run a create user, the name of the managed identity from external provider. But that requires that the context you're using in requires that the service account, that the SQL Server identity can actually browse Azure Active Directory. And that is not something that you necessarily want your server to do. And often you're not able to do that if you're running it from a pipeline. So we will convert the application ID, the client ID of the managed identity, to a SID. And then we will run this query here to create a user. And the magic part of it is that we are using not the name of we're still creating a user with the name of the managed identity, but we don't use from external provider, but we use with SID and type equals E. And that will allow us to create the user in our database. And then once we have created a user, we can give that user access to the database. I'm assigning it the data writer and data reader roles, but of course you can be as granular as you want, depending on what your application needs to do in the database. And then we will run the script against the database with the access token that we just got, and the query that we created up here. So let's try to run this. To go a little bit up here. So what we saw at the top of the screen here is actually the access token and then the ID of the managed identity once we get it. And then it will now to run the SQL script against the database. I'm not sure. Yeah. So it didn't really actually show anything. So if we look at the access token, which is what we're displaying on the screen here, we will take that and copy it. And then we can use a tool, for example, dwt.io on the web, which will allow us to open a DWT token and look at the contents of it. I think I get something wrong with my copy pasting here. Because it's not happy. Maybe I copied too much or too little. Maybe I can't do this. Yeah. Let's see. That's too much text. Hang in there. Check that we got it. I need to use this thing here to copy. Thunder. Copy. And let's just check again. Yes. Lowlands.Community.io. And it's actually be able to now shred my signature here. Wow, that's interesting. I think it's actually my, maybe it's my image or something like that. So it's showing me some properties about my account. Yeah. Let's see that. So it's basically just a plain JWT token Azure Active Directory is using to connect to the database with. And SQL Server supports that, of course. So let's try to run the app again, but maybe we can actually see, let's just go to that. So let's try to run the app one more time. And see, now we have connected, now we have allowed our managed identity to actually access the database as a reader. So let's see if we have more luck this time. Lo and behold, we're getting through to the database and getting our nice list of persons from the database. So let's see if we can see this initial error we got in Application Insights and learn a little from that. Yes, we can see there's a couple of failed requests here. So we'll drill down on the failures and look at this second failure, the error 500 we got. And you can see what's happening here is we are now looking in Azure Application Insights, and it shows the end-to-end tracing of what's happening during this request. So we are initially calling the endpoint to get persons, and then we are trying to connect to the database. And then there's something quite interesting here. We're actually calling a local service, managed identity credential get token, then calls get msi.token, which is a web service that runs on the local machines. You can see here 127.00. And it's actually the service that gets the token for us on behalf of the server, of the trusted server, and calls Active Directory to get the token. And then, of course, that token fails, and then we're getting the error that we cannot connect to the database. So somehow, app service knows that it needs to call this service, or the SQL client knows that it needs to call this service via some Azure library that does that. But how does the app service know where to that it should use this particular port to get the MSI token? We can have a look at some of the environment variables in our app service. Let's zoom in a bit here. There are a couple of related environment variables here. So the MSI endpoint is actually an environment variable in the app service, which can then be passed on to some software that is using MSI tokens. So this will be the URL, and which is called from the client SQL Server client driver, and then this secret will be passed as part of the request, ensuring that the validity of the trustworthiness of this call is as it should be. And you can actually see there's a parallel. I don't know why there's like a duplicate settings of this called identity endpoint and identity header instead of MSI endpoint or MSI secret. Yeah, maybe it's a point in time issue. I don't know. So let's go back to the slides. So I hope you have some questions for me. I don't have any more content at the moment. So my message to you is use user-assigned managed identity. It's certainly doable. It maybe if you're in a constrained environment, you can also do it. And definitely use user-assigned managed identity rather than system-assigned managed identity, and save yourself a lot of headaches and debug trouble. Don't store passwords anymore because you don't need to, and do enjoy a passwordless environment. All the code that I've just shown here is available on GitHub in a repo called Cloudburst demo. Don't ask why. And then there's also a link in the slides, which is also shared in the repository, which lists all the Azure services that has managed identities support, and also has links to more information about using managed identity with the individual services. That's all I had.
Yeah, thank you, Eric. Appreciate it.
Yeah, thank you for the session. There is one question in the chat, which asks that is from Sasha.
Yes.
He asked that whether Azure AD app registration is same as service principal.
Yes, it is. Service principal is basically just an account that Active Directory manages for you. You don't know anything about the passwords of that. It's not a user account, but it can act and behave like a user account. And in management, you can assign rights to this account. ABAC, access control rights for Azure resources, you can assign to this account, similar like you could assign rights to a user or any other user, named user or group. But you don't manage the passwords of this account. It's all system managed. So yes, it's similar concepts. Yes.
Yeah, and it doesn't look like any other new questions popped up. So I think we're at that, but no worries about not using Terraform. I think it's good that we get an example of both using Terraform.
No, it's nice to see that, and I've actually just discovered that Terraform looks quite a bit like Bicep.
Yeah,
yeah.
It's so, the other way around.
Yeah, or maybe the other way around. Yeah, what came first, Terraform, and then the Bicep team looked at Terraform and said, "Yes, we'll do it one better, and but for Azure only." Yes.
We need something that's a bit better than ARM template.
Exactly. We will do it better than, we will do it even nicer than Terraform. Less quotes. So
yes. Yeah.
No, but I've just discovered Bicep recently, and I think I'm actually quite impressed with it. And I really like. I prefer defining infrastructure as a state, not as a. You could also do what I'm doing here. You can also do all of this with PowerShell commands or Azure CLI commands, but you don't get the holistic view of your entire infrastructure. Even like with probably also with Terraform, you can even create diagrams based on this definition. So it's more like modeling an infrastructure. It's not just firing commands in random. It's actually it's like a description of your desired state, and I like that. I guess that's features of both. To visualize your infrastructure once you have defined it in Bicep. So.
Yeah.
There's also now just appeared tooling in Visual Studio. It doesn't have the visualizer, but it has the syntax highlighting and the IntelliSense that you also get in Visual Studio Code. So you can actually also now author Bicep files in Visual Studio. I usually use Visual Studio Code because it has a nice visualizer. Yeah.
Right. And also the links that you have on your slides, if you send it over to us, we will
The
paste it.
slides is also in the GitHub repo, but I can share the GitHub repo link maybe.
Yeah,
Yeah.
if you that
I
would
will send that to you.
yes, that would be great.
Yeah,
Yes.
because it has the slides, it has the codes, it has everything.
Perfect. Great. Okay. Thank you very much for the great session, Eric.
You're welcome, and thanks for having me.
Of
It's a
course,
pleasure.
our pleasure.
Yes. Pleasure.
Thank you.
Yeah.
And yeah, should we just play
Yes.
up next while we
Yeah.
prepare for the next session?
Yes, actually the next session is recorded. The speaker is actually not going to be here. So if you give us like a few minutes, we will make it prepare. We will be back, and then we will play the video. But maybe I can actually, while Martin, you are trying to set it up, I can introduce the speaker. Actually, that will be faster.
Yeah,
we can hashtag teamwork. Yes.
Yeah.
So the next speaker is Drew Kobala. He is a senior program manager for SQL tools and experiences at Microsoft. Oh, so we are colleagues, Drew. That's fun. He's also an open source advocate, which is awesome. And prior joining Microsoft, he has spent nearly a decade as a developer and database administrator. So in the video that we are going to play from him, he's going to have a short lightning talk about the source control and SQL databases. So,
I think I'll just remove us and then add him to the stage.
Great.
For presentation.
Let's talk about source control and your database. Databases are part of your application, but their objects might not be with your application code in source control. They might not be in source control at all. So let's talk about how we get them into source control and what we might get out of it if we put our database into source control. Of the two main approaches to bringing your database into source control, the first one is migration-based. There's open source libraries like DBUp and Flyway that allow you to keep a collection of scripts that take your database through its lifecycle. You're creating a car table in v1 cartable.sql. You're creating a manufacturer table in v2 manufacturer table.sql. And then you're going back to the car table and you're adding a manufacturer column. These are popular because they give you the ability to not only see the changes directly in those scripts, but you can also fine-tune how the changes are applied. It's a little bit more laborious when you're wanting to write through all of those changes, but there's trade-offs to that. Conversely, another way to bring your database into source control is through a declarative approach where you're using a SQL project which contains the whole model with one object per file. This builds to a DAC artifact, but then you have a SQL proj folder, and then you have a car table.sql file for the car table, and a manufacturer table.sql file for the manufacturer table. When you want to go back and add a column to the car table, you update that file itself directly. You're not creating a new file. The tooling in this case, DACFX or SQL package, then apply those changes for you. Once your database is in source control, no matter whether you take a migration-based approach or declarative approach, now you've got additional opportunities through the rest of what source control brings you. The first thing is the ability to then apply your database source control changes to any database. So maybe you're needing a development instance for building a new feature. You branch your application code. Why not be able to branch your database code? If you're using Flyway, you would use Flyway migrate, that command, to then stand up a development instance that matches your SQL code so you can work on your application. If you want to change your database, you're then still able to do that. If you're using SQL projects, you do a .NET build to build your SQL project, and then a SQL package publish to take that SQL project artifact and apply it to a development instance. So whether you're looking to update your application and branch it for a new feature, or whether you're looking to update your database, or both, you're now able to branch your database code and apply changes in more of a development pattern versus trying to always keep working in a straight line on it. The next step when we're working on an application is we push that code to a remote. Maybe it's Azure DevOps, maybe it's GitHub. But when you take your source code to a remote, there are additional resources that are available, like pipelines. Now, if you're using GitHub pipelines or Azure DevOps pipelines for your application code, you might be running tests, you might be doing builds. If you have your SQL code available in those pipelines, you're now able to use that database. You're able to stand up a test instance in those pipelines to test your application code against a live database. So instead of not touching your application code that calls out the database or stubbing it out, you're able to run better application tests. Now that's not it. You're now also able to test your SQL code better. For example, there's an open source unit testing framework called tsqlt, and you can write unit tests on your SQL code. So not only are you able to track changes in source control, but you're also able to test the code that's in source control. There's a SQL check code analysis framework as well available. So if you're looking to develop better SQL code, bringing it into source control gives you that opportunity. As we follow a application through its life cycle, you have V1, you have V2, you have V3.5, you have different versions. And with source control, you're able to tag your code at different junctions. Up until this point, we haven't really been acknowledging ORMs and what they bring, because a lot of times they're doing the migrations for the databases, and then you're not really working with the database code. If you still want to get your database code, one way is to be able to reverse engineer the database using SQL package. You're able to extract out a database into those SQL files using an extract target of either flat or a folder based on objects. So you still have a lot of flexibility, even if you're using an ORM, to have access to that source code. But you're also able to store or capture database artifacts, kind of like you grab your build artifacts. You can grab a DAC pack, which is that database model from a SQL project, and publish it as a build artifact. Maybe you want to be able to keep it at a later date, or maybe you want to be able to reuse it in other pipelines, but you have that flexibility now to grab those artifacts. So in this really brief introduction, we've thought for a moment about how we would bring our database into source control, but also why we would do that. What are some additional benefits that come from that? So if you're ready, let's go ahead and get your database into source control.
Yes, and we are back, and Sherry is muted.
Yes, we are back. I guess I was busy dancing in the background with the music, like everybody else. So that was great. So now we have actually we are going to have two speakers. Maybe let's bring the speakers on the stage.
Yep, I will add them. Here we go.
Hi.
Welcome.
Hi, Joachim. Hi, Santosh. Welcome. Hope you both also were enjoying the music.
It's all the Microsoft people who are muted.
That is right. I don't know. I have actually something called mute me, a button that that I never use, and it's supposed to help me, but yeah. Great. So I can see that we all are here, so we can get us started. I'm going to first introduce our speakers. So we have Joachim and Santosh with us. Joachim has been involved in a number of free and open source software projects for the past 15 years, from the Linux desktop and phones to the cloud, which is pretty impressive. Awesome, Joachim. He's currently working as a principal software engineer manager at Microsoft, and you're based in Portugal, right?
Yes.
Great. And we also have Santosh here. He's been involved in the CNCF space, which I want to know actually what it is. To be honest, I don't know what it is. And maybe do you want to tell us what it is?
I've been a contributor to a number of projects which are involved in CNCF. Yeah.
Hey, yeah, great. So Santosh is also working at Microsoft as a software engineer. Where are you based in, Santosh?
I'm based out of India.
Okay, great. So we have cross-continent speakers, which is amazing. And today, Joachim and Santosh are going to talk about Headlamp, which is an open source graphical user interface for Kubernetes. And they're going to show us how it's been built, how it can be extended, and how they have been leveraged for to provide a better UX for the Azure Kubernetes service users. This is going to be a super interesting session. We also, when we were looking at the CFPs, we all of us were just like, we want this talk. So yeah, here we are, and stage is yours.
Yeah, I'll just add the desktop so you can see, just to make sure that this is what you want to present.
Yeah.
All good?
Yeah, thanks.
Okay,
and,
we'll take it away, then
for...
myself and Sherry will jump out and leave you to it.
Cool. Yeah, thank you, and thank you, by the way, for accommodating both time zones, in India and in Portugal. That was quite amazing to see that we both could give the talk. Right, so as Sherry said, my name is Joaquin, and I'm here with my colleague Santosh to introduce Headlamp to you. So by now you already know that it's a Kubernetes Web UI, so let's just move on. I'd like to give an idea of what it is, because there are plenty of Kubernetes UIs out there, and there's all sorts of ways to categorize them. So I picked a few here just to kind of give a global picture of it. So sometimes some UIs require you to install certain things in the cluster for them to run, like a control plane or something like that. In this case, Headlamp is completely generic and doesn't really require that. It also doesn't require that you use a certain flavor of Kubernetes. It's supposed to be, again, generic like that or vendor independent like that. Another way to separate categories that some UIs require you to be deployed in a, as a web service. Others only work on desktop. We took the approach of building the UI with web technologies, but you can use it both as a, as a service that you deploy, or as a desktop application, like many applications work that way currently. Another way to separate is that sometimes, of course, the projects are closed or open or open core or something. In this case, Headlamp is completely open source, so it's 100% open. There is no like private functionality or anything like that. So another thing related to this is that we are actually applying to CNCF as a sandbox project. So we hope to get more news about that soon. But that just kind of emphasizes, boosting this community approach and transparency to the project, I hope. Another thing that kind of distinguishes Headlamp is that, from certain others, certain other UIs, that sometimes UIs may require you to run them with certain privileges, right? Headlamp in this case, the way it works is that it will it's basically just using the API server. So whatever the users' privileges, whatever the privileges the users have, that's the one that will be used in order to to access the API. So if a user, for example, cannot really delete pods, for example, then that's reflected in here. So it doesn't require any special privileges to run. And related to that, we actually we could take the decision of saying, okay, there's always a delete button. Maybe the delete button, for example, for pods doesn't work. What we try to do is what we call this kind of adaptive UI. So depending on the user's permissions, the UI tries to reflect that, right? So if you don't have the permissions to delete a pod, the delete button is not there. If you cannot edit a pod, instead of having an edit button, you actually have like a view button, because hopefully they can view the pod's code or YAML in this case. And that's the case with other functionalities, right? So last but not least, Headlamp is extensible using plugins, and we'll go deeper into this point. But and just to finish the section, the sidebar, the side sentence there that you hopefully have read by now is just the goal of the project, which is to be an extensible foundation on which users or vendors can build like these custom experiences on Kubernetes, right? So going to the next slide, I'll just give a quick overview of how Headlamp works. So I already said that it can be deployed in cluster or outside as a desktop app. So in this case, for example, you can think of it, of this example as you have 3 clusters, right? And then you have Headlamp. Headlamp has a backend and a front end. So what happens right now is that the backend is very lean at the moment. So it works basically as a proxy to redirect API requests to the Kubernetes clusters, to the API server, right? So when a client says, okay, I need to list the pods, or the front end needs to list the pods, it says the API request, the actual API request to the backend, plus the cluster on which to do that, and the backend redirects that to the cluster, gets the response, sends the response to the client, and then the view is mounted. Another hopefully more interesting thing in this diagram is how the plugins work. So the plugins, in the previous slide, there was actually mentioning front-end plugins, but the plugins are here are shown closer to the backend. The reason is that it's the backend that sets up the plugins. So when you have certain plugins, it's the backend that takes care of knowing where they are, sending them to the front end, and the front end dynamically loads them. This is what we thought to be the most secure approach, and also because if you, for example, have this deployed, then it's up to the operator that is in charge of running and maintaining Headlamp to be able to give the plugins. And if you're running this in the desktop, then you should have the plugins managed by yourself that you have in a certain location, and then the backend, of course, is running locally. So the binary is running locally, and it accesses that. But we'll get in more detail about this. Yeah, so what are actually the plugins? So when I said front-end plugins, you probably already figured out that they have something to do with JavaScript, since we're talking about a web UI. And they are JavaScript bundle files. In fact, like I said, they're set up from the backend, but dynamically loaded by the front end. Yeah, and in the desktop mode, if you have the plugins in a certain location and you change the plugins, or you add a plugin, remove a plugin, something like that, it gets reflected right away in the UI. That's only the desktop mode, because of course in the server you're supposed to get what the operator is giving you, so it works slightly different there, but it's basically the same end to it. And if you want to learn more, I got a couple of links there for later. Now, of course, it would be nice to have a way to manage the plugins, like to start a plugin, to run the plugin and all that, and we do have it. It's called Headlamp plugin as a CLI tool, because we're very original, and you can install them from npm like that. So the first command installs it globally in that case, and then you can create it. It will create the boilerplate, and you're going to get a directory. If you go into the directory and just do npm start, it gets built, and you can see the changes in the UI. That's basically the workflow. Now, right, so talk about the plugins and how they get loaded and all that, but actually what can you do with them, right? So since they are front-end plugins, you can already guess, I'm sure, that they can change stuff in the UI, and you would be right. So these are 3 simple screenshots of examples. So these are coming from the example plugins we have in our repo. The first one up there, it's like a section. So you can of course add sections. That's a very basic, would be a very good guess that you could do that with a plugin. So you can create like a whole section to display whatever you want. Like maybe you want a list of pods that start by letter B, whatever, right? Another thing that you can do is also changing the branding, for example. So the middle screenshot shows how a plugin has changed the logo to be that example. But also it does more stuff. For example, the last screenshot there, it's actually showing a menu on the desktop application. So that's like a native menu, not a menu that is running in the web UI. And it's also been changed by the plugin, which added that last menu item called Chat with Us, which opens a link to the Headlamp Slack. But what's much better than showing you screenshots and talking about how it works is actually to give the mic to my colleague Santosh, and he can actually show you a real demo that will for sure work and not break, because that's how presentations go.
Thanks, GP.
Go ahead, Santosh.
Before jumping into the demo, let me quickly run Headlamp and show you around the UI. Right now, Headlamp is loaded and it has picked up 2 particular clusters from my kubeconfig. That is a file in kubeconfig file. And right now it has 2 clusters, Docker Desktop and another cluster called Santosh Headlamp, which is running in Azure. Let me quickly jump into the Docker Desktop cluster and show you the UI. Yep, shows us a quick dashboard with the number of pods. You can jump into namespaces, access the Kubernetes resources, and etc. And as Joki mentioned, Headlamp is adaptive and can choose to show or hide certain things based on the availability of resources or else access to the particular user. If I quickly jump to the cluster which is running in Azure, you will see it shows the CPU usage and memory usage, whereas in the previous one it didn't. This is because in this cluster the metric server is up and running. So Headlamp can adaptively show and hide certain things. You can also go to the pods, look at the logs, YAML, etc. So today we have two plugins for demo. One is a simple plugin which showcases how a vendor can extend Headlamp to link and integrate Headlamp with their own services. I'll jump into the terminal. These are the two plugins: Azure Help Links and Headlamp Azure. I'll open this in VS Code and run the plugin. Minutes.
So this usually takes a little while just because it's checking if the tool is up to date, but it's only in the beginning.
Yeah.
And depending on your internet connection, I guess.
Yeah. Cool. Right now, if you see the UI, you should see this button which is added to the top bar. It says Open Azure Portal. You can click on it to quickly jump to Azure Portal and then access your services in the cloud. And it also added this particular sidebar button called Azure Help. This is simply this just adds a simple rendering of a README file, and I'll also show the code.
Can you increase
Yeah,
the zooming
yeah,
just
one
slightly?
second. Yeah. Is this fine?
A little bit
Cool.
better. A little bit more would be better on my screen. Yeah.
Okay, cool. So if you see this, the register app bar action and register route and register sidebar entry functions are being imported from the Headlamp plugins library. The register app bar action adds this particular button to this top bar, and similarly the sidebar action adds this here, and this particular URL Azure Help is dynamically added by the plugin. So this is a simple example of how users and vendors can extend Headlamp and integrate it with their services. And for the next example, we'll see how to dynamically log into a cloud provider and then dynamically fetch the kubeconfig and set the cluster, like so that you don't have to deal with downloading the kubeconfig files and then setting the cluster and stuff. Just a second. Before that, I'll show you how easy it is to change the values here. So right now, if you change this, the the headlamp plugin is looking for changes and then building the plugin and moving it to the place where the backend is going to load it from. Yes. So it changed from Azure Help to Azure Assistant. So the downline is like it is very easy to develop the plugin since the CLI gives you the opportunity to run it in development mode and set up the basic structure of the plugin. Yep. As I was saying, next we'll jump into another demo where we'll run a bit more complex example where we load the clusters from a cloud provider. I'm moving into the headlamp Azure folder and running npm start. We quickly restart the backend also once. Uh, Looks like 1 second. I think the demo gods are not on a site today. Once. Let me quickly check what is happening. Ah, let me give it another shot.
Yeah, so the demo that Satoshi is showing, it's very experimental in some parts of it, but I think it's just trying to pick up the different plugin. But I think it's gonna be
Yes.
there in a second.
Hmm, I don't know what is happening here. For
Just
some,
restart the backend. I think should be okay.
yeah, cool. Yeah, now it is here. Sorry for the. Yeah.
Yeah, it's
So right
nice.
now, yeah. So right now the plugin is loaded and it has added this particular button to this cluster chooser. Right now we can add a cluster from Azure. It redirects you to the Azure portal and you can log in using one of your accounts. And cool. Right now it is listing the subscriptions which I have in my account and I have a cluster called Azure Plugin Dev. I'll set it up and then move to the home directory. Yeah, if you see here, the plugin has loaded this cluster, and since it is loaded from the plugin, it has changed the logo here for reference. And yeah, you can directly go access the objects in your cluster and everything. Pretty simple. So this kind of extensibility allows any cloud provider to easily log in and use their clusters in Headlamp. And this is not particularly specific to Azure, like any other cloud provider can do this. This also reduces the hassle of downloading the kubeconfig file and setting it up. This is the two demos which we had prepared for the day. Back to you, Jatin.
Thank you, and claps to Santosh for enduring the demo and make standing to the demo gods again. All right, so as Santosh showed you, there were two plugins in this example. One was kind of basic and did what I showed in that slide about the overview of functionality. So you can change the branding, you can add a section, a route, and all that. But you can also use it to assemble a kind of much more involved user experiences. So if you're a user and, for example, you want to give users access to the AKS clusters in a way that they don't have to set up the kubectl config, which may, one could argue it's a bit more secure in that sense. You can have a plugin that goes from the moment of, goes from putting a button, having guiding the user through the login views, and then getting back the information and assembling, basically setting up the clusters like that. And so I hope this kind of illustrates the power of the headlamp plugins, and and of course when you develop them, you never run into issues like this, like that. So I hope that our point got across. It's a vanilla generic UI with capabilities that you can extend through plugins. If you want to check it out better or even test it, we have it. You can quickly test it, or even just use it. Use it just by using Minikube. There's an add-on for it. And then depending on your platform, you can use Homebrew, Chocolatey, or Flatpak, for example, to try it out as a desktop app. If you want to learn more, we have a contribution page. You can also say hi on the community Slack. We have a channel there. And thank you so much for attending.
Thank you for the nice presentation and awesome demos. And yeah, it was an experimental demo and it worked, which is awesome. I don't see actually any questions in the chat, but for you who are watching us, if you have any questions, you still have time. We have both Santosh and Joachim here. One question I have for both of you actually is that, is there any link to your slides or some of the links that you presented there? Again, it would be good if you send it to us so we paste it in the chat.
I will definitely send it to you. I thought by using them in this platform, they would be linked, but yes, that's a good point.
Because it is broadcasted on YouTube and it's not linkable.
Okay. I'll send it to you, and then you can send it to the people. I hope the lack of questions is because we were so clear about the slides and everything. Everybody understood it.
Well, actually, I have a question because I think it was really interesting to see. But I'm curious, like where do you envision that this is run? Because it's like it seems like you can run or have an overview of multiple different clusters. So maybe you wouldn't put it in to a running cluster and use it as a view of that, but maybe have it in something like Backstage, if you're familiar with Backstage from Spotify.
Mm-hmm.
If that could be a point of entry, like that you can kind of couple those together, and so a team can get access, could kind of incorporate Headlamp into Backstage and then use that to get view into their clusters, which might be more than one, or how do you envision that?
Yeah, so definitely the multi-cluster view has two things about it. One is what you said, like you can run it in once and then you can configure other clusters. That should actually work nowadays. But then we also we have it in our plans, in our roadmap, to kind of redesign that basic, like the first view that when you enter a cluster, it's going to be an aggregated view of multi-clusters. So our idea is actually not to show one cluster at a time, but to show like a highlight of all the clusters, right? And then you will be able to kind of group them. That's at least our intention. So you can group clusters by some logic sense, and so that's those are the two things about just showing the multiple clusters. But then the thing is that since Headlamp can work on a desktop, but also deployed and all that, there are many different use cases, and people use it in different ways. Like for some people, the desktop is definitely more important, and we have users like that created a plugin, and now they're distributing the desktop version with the plugin. Then we have other vendors that have plugins that they created, especially for example for custom resources that they want to display in a certain way, right? And what we're trying to do is to make it run on as many platforms as possible, so to say. So platforms not in the sense of the desktop platforms. I think there are mainly three, and those are covered. But like we have also a Docker desktop plugin coming along very soon that Santosh is working on. In this case, and the case with Backstage would be another case of those, I think.
Yeah. Okay. So today you could run it in a Docker image on your local desktop, and then get a view of your clusters, for example, or would you just run it? Is it just like it's just npm run or start run, and then you're running on your local desktop, or?
Since the backend is in Go, we kind of keep those separated if you want to run them in what we call development mode. So you run the backend and you run the front end locally. But otherwise it's just a regular desktop application, and we do. And when you host it or you deploy it in some server, we have of course the recipes for Kubernetes. So it just runs the image that we have, like the container image, and we have also some articles about how to run it with plugins there and all that. So that's I don't know if that answers your question.
Yeah, it does. Yeah, but it's interesting. It seems like it's pretty straightforward to actually create plugins. If I understood it correct, then the way to create plugins is simply by writing TypeScript.
Yeah. Of course, the Headlamp plugin CLI works. It helps, of course, and we're trying to extend that to also include things like migrating if there are certain changes that we need to do. So you could run the Headlamp plugin, and it would detect that you're running against a version that needs some updates, and hopefully perform those updates for you. Otherwise, it's TypeScript or JavaScript, but we recommend TypeScript. Actually, the one thing that normally what we want is about the development of the plugins is that the more users give us feedback, I think the better it becomes. So we took a very conservative approach to what we could expose in the beginning, because we were not sure, okay, should we expose this, and then next week maybe we break it because we want to change how it's done. So instead we exposed a couple of core functionalities, and then it was like users came to us and we're like, okay, now we need to actually change this thing here, which is not covered. So that's when we go and we change that, right? So not every single thing is yet customizable, but a lot of things are, and we try to make sure that the changes we do can be carried forward, at least in a backwards compatible way, so you don't have to keep changing your plugins all the time.
Yeah. Sounds good. Well, thank you. I don't have any more questions, but super interesting.
Good questions. Thank you.
Yeah. Thank you very much for the presentation and all the discussion afterwards. I guess I can see that our next speaker is also here. So thanks again, Santosh and Joachim. Hope to see you on our next events in the other conferences.
Yeah.
And thank you very much for your help.
Yeah.
Of course. Our pleasure. Thanks for the presentation. Bye. All right. And should we go ahead and add Mikhail to the stream?
Yes.
There we go. Hi,
Hi.
Mikhail.
Hi, Miali. And welcome to this session. So,
You're
what we're
unmuted.
going.
We should just start off by saying, remember to unmute.
Yes. Button to press. And use there.
In StreamYard.
Okay.
There we go.
I think
Yes.
now it's fine.
There we go.
Great. So I'm going to first start by introducing Mihail, and then we are going to share your screen, and then the stage will be yours. So Mihail is currently working as a senior solution architect at EPAM Systems. Where are you based, actually, Mihail?
I'm based in Sofia, Bulgaria, but I travel a lot, so probably sometimes it's confusing people to say where I am.
Yes, I know that feeling. Great, but now we know that you're based in Bulgaria, which is great. So yeah, he worked many years as a technical evangelist in the area of infra.
UI components related to Microsoft technologies. Yes,
Yeah.
it was a nice time many years ago.
Yeah, great. And so today he's going to talk about Azure Cosmos DB serverless. So he's going to show us how to choose between provisionized throughput and the serverless, all the best practices in the solution design and cost estimations when you need to use Cosmos DB serverless. And he promised a lot of real life use cases and demos, which is amazing.
Those we love.
Yes. Great. So I guess we can say stage is yours.
Yeah. If you share your desktop, then we can add it to the stream.
Thank you for the introduction. And I'm sharing now.
And for those of you who are watching us, if you have any question, please put it in the chat. We are going to bring it to him after the session.
Yes, there we go. So stage is yours.
Thank you very much. We will talk today about Cosmos DB serverless. It is one of the favorite features, especially for me, regarding to Cosmos DB, because many people want to use the whole power of this multi-model polyglot database as a service offered from Microsoft, but sometimes small users, small companies, and also companies where they want to use Cosmos DB for not so heavy loaded solutions want to have cost optimization. So Cosmos DB serverless is what we have as good option to optimize our cost and to have coverage of many use cases where in the past probably Cosmos DB was a little bit above the budget for such solutions. We will talk about some concept details. After that, we will have comparison between provision throughput and serverless to be clear where we have specifics. We will discuss a little more about estimation, because estimation is the most important part to know how much it will cost, use cases, and demos. I work in Microsoft Azure area from probably 13 years. So we have a lot of interesting cases, also including IoT solutions with Cosmos DB. And I will demonstrate comparison between case when we have serverless solution and when we have provision throughput. Well, let's see what is the important when we talk about Cosmos DB with provision throughput. Cosmos DB is growing. We have already 6 different APIs, adding from last year also PostgreSQL, and we have a lot of different options to implement Cosmos DB in different solutions. I'm adding this information about APIs, which is probably well known for many of you, because here the interesting part is where we have provision throughput and where we can have also serverless implementation. For all APIs, excluding Postgre API, we are able to use serverless Cosmos DB, and this is a really good advantage for current users of Cosmos DB and also for people who want to implement it solutions with Cosmos DB in the future. There are some specific details regarding to distribution. When we have serverless solutions, we will see we can have only different zones, but not deployment in different regions. There is reason why to do that. I will explain details. And regarding to most of other details, we can understand pretty easy how Cosmos DB serverless works based on general knowledge about provision throughput. What I mean, when we have Cosmos DB provisioned in different regions, we can have higher availability, but from another hand, we have less flexibility. Even in one region, we have again 4 digits as SLA, and it is quite good when we need to have this flexibility. So I will not discuss a lot of details regarding to Cosmos DB in general. I'm a big fan of Cosmos DB, but I suppose most of people at this conference know main details about this multimodal database, mostly focused on NoSQL. We have database as a service. This database is important to be optimized, like performance and cost, and this is one of the most important things which we can have with serverless. When we talk about serverless, actually we have 2 different aspects. First is serverless as a solution, as component, which is not needed to know where actually persists data and how it is deployed. This is something which is not only related to Cosmos DB, but to many other services. And the second specific is exactly on Cosmos DB, where we have this flexibility with throughput, which can be dynamically changed, and we will pay only for what we use. This is the most important. In many cases, in reality, we have workloads which are volatile. That means we have at some moment huge load, at other moments we have moderate or very low load, depending on data which need to be processed. For such solutions, serverless give us very good opportunity to optimize the cost. When we have fixed capacity, it is very good in a cases when we can predict consistent, usually high load. In this case, we can get the whole advantage from provision throughput. But when we have volatile workloads, we can prefer, of course, more flexible solution with Cosmos DB serverless. We will talk about these scenarios in the next slides. As I already explained, the focus here will be mostly serverless throughput, not serverless as a component of the cloud solution. From billing perspective, the most important is serverless mode is when you pay for what you use. As for many cloud services, which is the general idea to have cloud solutions. Initially, Cosmos DB offered provision throughput, and it was predicted mostly for payloads where you have high load and you have a relatively predicted data load related to these scenarios. Cosmos DB usually is difficult to be estimated as cost in simple way. For estimation, we are using so-named request units. Request units is specific metric which brings the effort which is done from the computing platform when we have relatively simple message up to 1 kilobyte and up to 10 properties when we read data from Cosmos DB. For other operations, usually we have more request units. Depending on the size of the message, we have more or less request units. You can make in real situations requesting in real time of this information using portal. You can see your requests and request units. So that means you can see how much computing resources are used when you make specific queries. And here exactly is the most important advantage when we have a situation where we pay for what we use. We can have flexibility because some queries request more units, some queries request less units, and we have a very different load in most of the cases. So I will show you in the next slides also how we can compare different types of containers regarding to our cost perspective. Usually provision throughput is related to payloads where we have a lot of requests, but it is good to know that also you can use it for free tier in each Cosmos DB subscription. You can get one account where you can have free tier with limitation up to 1,000 request units per second, like has throughput and limitation regarding to the storage. This is what you can use to learn how to work with Cosmos DB. But if this is not enough, or you have more different cases, serverless is also a good option to use Cosmos DB for development, for education, for learning. It is one of the good options actually to have such kind of flexibility. When we have serverless, there are some limitations. Initially, when serverless mode was announced in the end of 21st year, it was with limitation 50 gigabytes per container. Now we have increased this limitation. We are able to use up to 1 terabyte storage. It is still in preview. You need to have different containers, but totally storage now in serverless mode is up to 1 terabyte, which gives us additional options to use serverless mode also for scenarios where we need to persist more data. Additionally, we need to know that only one mod is supported for specific Cosmos DB account. It is possible to have only serverless mode if we create Cosmos DB account in this mode, or we need to have only containers with provision throughput. So you need to decide initially how you will make your containers, which kind of throughput you need to have. It is not possible to convert one mod from another. If you need to change the type of provisioning, you need to have new account and to redeploy your Cosmos DB. Of course, it is not something which is difficult, just I'm explaining specifics which you need to consider in such kind of scenario. It is also important to know that there are limitations regarding to different regions. It is not possible to have deployment in different regions, as already explained. I will go a little bit ahead because we have limited time, and I would like to make short comparison, and after that to show several examples. Usually when we have provision throughput, performance is related to also minimum latency, which we can expect. This latency theoretically is a little smaller when we have provision throughput than in serverless. But in reality, for most of scenarios, you cannot feel such kind of difference. So it is not possible for most of scenarios to feel the difference if you have Cosmos DB with provision throughput instead Cosmos DB serverless. What is important when we need to have estimation for our cost, we can pretty easy make calculation how much it will cost, because we have not much time. I will just move several slides ahead. When we have provisioned throughput, you need to pay for throughput and storage. For serverless, you are paying only per number of requests. Let's go to the estimation part. I'm going a little bit ahead. Because it is really important to show these details. Imagine that we have payload where you can approximate a number of request units per month, for example. Depending on total load and total number of request units, plus restriction related to maximum number of request units which you can have on pikes. When we have high loads, you can choose serverless mode for situations where you have not so big numbers of request units. For example, if we have 20 million request units per month and we have not very high pikes, for example, up to 500 request units, you see that we have with provision throughput around $30. for the same container, and we have only 5, 6 times less when we have serverless mode. If we have very high number of request units, that means if we have high load scenarios, it could be the opposite. If we have, for example, 250 million request units per month, of course, it is subjective, but for most of the scenarios, it is quite high load. You will have the opposite situation. In this situation, you will have more expenses in serverless mode. So it is very important to know what is your estimation about total number of request units for your billing period. And it is also important to know what is the higher number of request units when we have some spikes. This is the most important. We can monitor in the same way like for provision throughput our containers. We can check the usage of our Azure resources and to have clear vision what is possible to have. In scenarios, usually provision throughput is good for education development, as I mentioned, very often for backend solutions, for databases, used for backend solutions, for back offices, for different organizations, even for big enterprises. Usually for these kind of solutions, we have not so much data load. From another hand, it is possible also to use it for more complex solutions if our load is not very high, even for IoT solutions. What I will show you now are several scenarios where we can use this provision throughput and to compare it with serverless and to see if we can replace provision throughput with serverless and to have the same functionality on a lower cost. Well, I will try to show you one sample application. This sample application includes IoT scenario. We have device represented from device simulator, which is realized here. I will start this device simulator and we will send messages to IoT Hub. From IoT Hub, we will have configuration of our endpoints, and it is possible nowadays directly to have output from IoT Hub to Cosmos DB. So I will configure it in 2 different ways, and you will see the result from these 2 scenarios. Let's run our simulator. So I'm sending simple telemetry messages with information about several metrics, vibration, speed, temperature, and information about sensors. I have already prepared IoT Hub. I will share this screen. I created one IoT Hub where I have message routing, and I prepared for message routing custom endpoints. One custom endpoint is for Cosmos DB with provision throughput, and another one is Cosmos DB instance with serverless. I will show you these already created databases because we have no enough time. For Cosmos DB serverless instance, we have one database and one container vibration where we are able to store messages. When we create such kind of instance, we cannot make any settings related to region deployment, to multi-region deployment, and also to setting of some provision throughput. We have at the same time another instance of Cosmos DB where we have again container. This container give me a second to show you this container. Yes, is with the same entities. And additionally, we have also another example which I will demonstrate. So let's show what is the result. Now we have here our telemetry messages. Currently, we have in our IoT hub configuration where message routing is using serverless instance. I'm going to the serverless instance, and you can see here upcoming messages. Now I will change this. I will stop the generator. I will change the IoT hub routing, and I will show you how it works with another database. Because we are a little bit behind the schedule, I'm not sure if we will have time to show you the second example because I have another one, but I will try at least to make this one. So I will try to change here the endpoint. I will save it. I will run again our device simulator, and I will show you in the new database also data which is already stored there. So we're almost ready. I'm starting again our device simulator. Device simulator is running. We are going back to our Azure Management Portal. I will show you after a second what we have. Okay, I'm showing now the second database, and in the second database we have also this table, this container, vibrations, where we have the same data already stored. Here, with this example, it is difficult to feel the difference regarding to the performance. I have another one example where I can show you numbers regarding to performance. Just one question to organizers. Is it possible to have one more minute for the next demo?
Yeah, I guess that should be fine.
Okay, thank you. Well, I'm stopping this sample and I'm going to the next one, which I already prepared. Next one is related to generating messages which are stored in table API. Just I'm demonstrating again different API with serverless and provision throughput. I'm starting first sample with provision throughput. In the demo, you will see also numbers as time which is needed. It is actually performance demo. For demo purposes here, we limited the number of records to 100, but for more serious tests, of course, it will be with much more requests. You see some numbers now. I will run after the first sample the second one with serverless implementation, and you will see the numbers. We can compare it. Premium temp table, serverless. So this is the same implementation of our simple scenario with Cosmos DB serverless, table API, insert operations usually are more costly. I will show one to another samples with serverless and provision throughput. Of course, it is quite subjective. Depends on current network and what is the situation with the load of Cosmos DB in specific regions. So we can see here that regarding to this example, we have at some metrics a little more time from serverless, but again, it is in the context of milliseconds. So what I can say with several words is if you need to have the whole power of Cosmos DB, for now without Postgre API, for solutions where we have very different load, we have volatile load with periods where we have low load and periods when we have spikes, or we have solutions with not so high load in general, but we need to take advantage of all these nice functionalities from Cosmos DB. I kindly can recommend to try Cosmos DB in serverless mode, because you have a much cheaper solution in scenarios with low load and volatile load. And from another hand, you have all features of Cosmos DB without, again, Postgre API for now. You have almost the same performance in 99.99% of scenarios. Probably you will be not able to feel this difference. I intentionally show here performance samples to see that there is small difference in the numbers, but when I show you the previous scenarios, you saw that it is difficult to feel the difference in performance when you have some general scenarios, for example, not very loaded IoT system or some enterprise solution. So this is what I wanted to demonstrate today. Cosmos DB serverless, much better option to take whole advantage of Cosmos DB on lower price and better flexibility. Thank you for attention, and if you have any questions, of course, I will be glad to discuss it.
Thank you very much for the session and all the live demos, which they all worked, which is, we always know that is a challenge. Great. I actually don't see any questions in the chat. So if you're listening to us and you have any question, you still have chance to ask the questions from here. I will give a few minutes. I mean, a few seconds.
If there are some questions later, I will be able also offline to answer. I'm really happy if I can help with any information about Cosmos DB and serverless mode. It is something which also, as architect, I'm implementing in different solutions, and personally, I'm happy, so I can share this experience.
Yes, great. Thank you for offering your help. You can always reach out to Mihail on his social media account. You can actually, yeah, he also even has his Twitter handle here. And if you go on the website, his contact information is there. Thank you very much for joining us today, and hope to see you around in the other conferences.
Thank you for the invitation. It was an honor for me to join this conference.
Yeah, thank you. Bye-bye.
Thank you. Bye.
So, I can see our next speaker, Jens, is here. You have to bear with me alone since Merchant left to make sure that our in-person meetup, which happens in a couple of hours, is ready. So let me actually add Jens to the screen. Hi, Jens.
Hi, Sherry.
Hi, good to see you. It's been a while.
Yeah, it's been quite some time.
Yes, right. Jens is probably you know him from the community. He has a couple of decades in the industry, focusing mainly on business intelligence tools. But he is also very keen on the PowerShell, C#, and Azure in general. Currently, he is a hands-on partner at Catman Solutions, driving the business intelligence as a service team. And he's been 6 years in a row. Oh, that's a lot. He's been awarded as a Microsoft MVP in the data platform.
Yes.
And yes, he is. He's normally, you can find him on the meetups and the conferences here in Copenhagen or around. And today he's going to give us an introduction about the Custo Query Language, or KQL. And
Yes.
If you share your screen, then I can start the presentation.
Let me see if I can get the right screen to share. Should be this one. So let me know when you're seeing it.
I can see it here. So yes, during the session, if any of you have any question for Jens, just put it in the chat. I will bring it around to him at the end of the session. So stage is yours, Jens.
Thank you. Thank you. So this is obviously an introduction session, so we will not be going too deep into KQL and the techniques behind. I will, well, let's just stick to the agenda, which I'm going to, well, if this works. No. Yes. Okay. So the agenda for this session, I'm not sure if I have a strict back end at 4 o'clock, since Michael ate some of my time, but let's see how far we can go. Just a short intro on me and where I come from. Cheryl was kind enough to actually introduce most of it. Then we'll go into a gentle introduction to Azure Monitor, and by gentle I mean really just dipping our toes. And then we'll kind of build upon a delicate introduction to KQL, some of the most standard features of the language, and then I'll show some full throttle KQL analytics queries so we can dive into some of the outcomes that we can use these for. Well, as Sherry said, I work with Catman Solution. I've been with this company for 10 years over 2 periods. I'm currently partner and Cloud BI architect here, working with Power BI, Azure Analysis Services, various number of languages, including KQL. You will see why this is important to us later on in the presentation. As Sherry mentioned, first and foremost MVP, then coffee roaster at home. That's something I dive into in my spare time. I also hold a number of certifications and pride myself to actually renew these as we get new content to them. Some of the most recent additions to Catman Solution, just for you to get a sense of what is it that we do. We serve these companies and their business intelligence from the fast-moving consumer good industry, so that they can track all their sales in every store in the country, both in the Nordic region, actually. All right, enough beating around the bush. So first off, if we want to know about KQL, you can have kind of 2 entries into that. My entry into it is through Azure Monitor. The other entry is through AEX, but that's a more kind of technical, detailed session, so someone else has to take that. But Azure Monitor is something that sits in Azure. It's an Azure service that provides performance and availability monitoring for applications, as well as services within Azure, even other cloud environments, and you can even monitor on-premises environments as well. Azure Monitor collects data from multiple sources into kind of a common data platform, data lake, if you will, where it can be analyzed by you for trends and anomalies, and even Microsoft uses this as well. So I think Microsoft Defender is actually relying on this. Cloud Network Watcher collects data into log analytics as well, so they can, draw insights out of that data that they collect. So back in 2018, Microsoft combined Azure Monitor with log analytics, application insights, and so on into a single service. And most of the functionality actually moved on into the new product. And the most maybe important thing to know about the cost of Azure Monitor is that it's charging mainly for data ingestion. So whenever your application or your service logs into Azure Monitor, it has a cost. There's an intricate cost detail that you can look up, even I think through the Azure calculator, which may be the easiest way in. But also if you Google for Azure Monitor, you can find cost and prices at the landing page for that. Some choices you make will affect price. I mean, the amount of data that you put in is obviously the first one. You can then archive the data somewhere else if you want to, persist it longer than the standard 90 days period. And then you can actually also extend that retention within Azure Monitor, which has an effect on cost as well. Searches are not really that costly. It's not what's driving the cost of Azure Monitor, but it has a cost attached to it. You can access Azure Monitor obviously through the portal. You can access it through CLI, PowerShell, and also using REST APIs. This session is about querying data collected in Azure Monitor, and we do so using KQL. And there's a history to the name KQL, Cousteau Query Language, which is named after the famous French diver, photographer, filmer, about diving into data like that. But without further ado, we will go dip our toes in KQL, and I will just start shortly in the portal, and let me know if my resolution is okay. I can maybe zoom in a little bit. The landing page for Azure Monitor, when you go in there in the portal, looks like this currently. This is an ever-changing environment within the portal. So, but the main thing that we are interested in is these logs. So this is where all the data is queryable. And as we can see right beside is the alerts, which we're going to be touching briefly as well. And then there's the workbooks, which is the new environment which they're kind of transitioning into. So you will see some alerts in some of the environments that I'm in that we need to transition those into the new layout within a time frame of a year or so. So there's plenty of time to react if you have something running already. But okay, so we need logs, and we need services, maybe even applications to log in to these logs. And you can configure a service to log into this workbook environment or log application using the diagnostic setting of a service. So currently this is our analysis services, the Azure Analysis Services server that we are running some of the data models, the Power BI data models in our production environment on. And in the section monitoring, we have a diagnostic settings. So these diagnostic settings you can configure. And this is a section that is part of all Azure services. So you can actually set up each individual service to log individually, or the same in the same log account across all services, or if you have the preference, you can log into individual log accounts. We can have some different settings for each service. Obviously, some of the variations are some of the services available, or the metrics or log alerts from each service may differ. In this case, we log all engine and service categories into this log analytics workspace. So if I want to query something on top of this, I have to go into the log analytics, tabular log analytics production. And this is something we actually use actively to trace if someone is misusing our service. we run Power BI on top of this output and identify long-running queries and so on. So this is one way of actually interacting with that data. And we actually use KQL to track all of these changes in this log analytics workspace. We can also send it to a storage account where it will be stored as JSON. We can stream it to an event hub. We can then ingest these events into any other solution, or we can even send it to a partner solution. This means that if you are implementing as an IT professional something in another tenant, you could have it log into your own tenant to log into your monitoring solution, which is quite nifty. All right, so if you have set up this logging scenario, obviously you would have a log analytics workspace created beforehand, and luckily I have so. And this is configured and is pumping data into this log analytics workspace. So let's go see what that looks like. I'm operating with two application insights log workspaces. One is called DevOps and one is called DevOps Prod. And this is for various scenarios that I want to showcase in this session. Obviously, this application insight is to enable us for our custom application. We've built a web application, some web jobs and Azure functions and so on, and they all log into this workspace using this instrumentation key up here. And we can then kind of collect all of the events and metrics from all of the various applications that we have running into this single data repo. Going into the logs of this, again, I'm in the monitoring section under logs. I will be presented with actually mainly first a kind of a wizard stuff. All of these queries are usually used. So Microsoft offers up kind of a fresh plate of these queries are run often, but they are probably targeted towards infrastructure heavy setups. So they are depending on virtual machine live signals and so on. So that's maybe a different direction than we are using these logs to visualize. But we get presented also with a number of tables or databases. They come by a very, very broad number of names, and the ones that are maybe interesting for this session will be these custom events and custom metrics. Obviously, exceptions are always very nifty to dive into. And as you maybe realized, I can double click on exceptions, and then it's writing some code up here in the code editor. Actually, this is the equivalent in SQL to select star from exceptions. So I don't need to write anything else but this to actually select from exceptions. So let's see if there's been any exceptions for the last 4 hours. There's been one. So one exception within the last 4 hours. And if I wanted to expand that to 24 hours, there's been 3 exceptions. But what if I don't want to kind of click and select all the time? You can see maybe there's a grayed out section here, set in query, which indicates that I can actually set my range that I want to query in my Kusto expression. So the way to extend the select statement, if you will, is to kind of like PowerShell, add a pipe. Now, code completion tells me when I hit space after the pipe that these are your most sought after or most used query extensions that you want to add to your query. And surely enough, where is the first one? We always seem to want to filter our data down to, a smaller set or maybe a more narrow set. So I'm always struggling with periods and time and date stamps and so on. And it's like they thought about that in designing the KQL language, because I can actually say that I know that there's a timestamp in here, it's a column, so to speak, in this table. And I can say timestamp greater than or equals, then we have this very nifty function, ago, that takes a time span. This means that my query not only queries the duration that I want, but also is dynamic. Because in this, I can note the duration in terms of 1 hour or 1 day, depending on what I want. So no exceptions in the last 1 hour, and you can see that the time range is set in the query as we were offered. If I say 4 hours, we should get 1, and 24 hours, we should get the 3. So I can also say 1 day, and I get the same result. So this is a nifty way in KQL to actually make your expressions dynamic. I could also add pipes endlessly all the way down, so to speak, but I can even add another where clause. I can add as many as I like, and the query engine will then add all of these up before executing the query on top of the storage. So I could also, for easing myself of the task of querying, and expand one of these, and I say, okay, so I only want these. There used to be a method. Oh, they taken that out. There used to be a link, so you could actually click. Okay, so it's just on the context menu now. Okay, so let's see if I right-click on method. I can say I want to include only these exceptions, and now you can see it added another where clause. And if I expand well, it's still 1 day. So if we only query the top 2 lines, I should still get 3. If we query the entire expression, I'm getting 1. So you can see I can add where clauses, so I can actually, click around if I want to, and by clicking in the result set, I can actually generate my query. That's also quite nifty. If we stick with our 3 exceptions from before, I can order those, and I can order those by either timestamp, and then ascending. It's the same order as before, but I can also order them ascending. I can order by any column that the result set returns, so that I can present the most important, maybe severity level or something else that I want to order my output by. So that's also possible in the AQL language. Then I can also say that maybe I don't want too much work to do, so my query should always list the top two. And now we will just add the order, severity level, sending, and just select the top two. Oh. Severity. So now I only get two result sets back, but in fact, I'm hiding away the fact that there is three, but since I don't want to work too much today, I'll take the last one tomorrow, and I'll rerun my query and see if it's still there. So I can, make a top 10, top 100 list of anything that I'm querying in my data set. I can also say that I want to extend, or maybe I'm seeing too much. Actually, I just want to see some of the columns that I have here, and I have a number of options to either project in, so to speak, that this is an explicit list of columns that I want to see, or I can project away some of the columns. If there are more columns that I need to opt into, it's maybe easier to opt out of some of the fewer ones. So let's see, I'm going to select timestamp. It's always nice and handy to have that. And then the maybe the method and the severity level. So by projecting that, my end result is actually consisting of only these three columns. If you noticed before, let's run this again and expand one of these. I have some details, and this is expandable as well, containing more information. So this is sort of a JSON format, kind of navigation-like style that you have in here. So, and this you can also, let's just select this, custom dimensions. And we can see that we get all of these in here as well. So we get the custom dimensions, and we get all of the child elements within that element. But I could also say that I want to extend custom dimensions. Let's call this message. So in this top item, I get a message column. This is the one that I created here. In this line, I extended the projected output of the query with another column called message, and it has this as source. So it's giving me one kind of element here and blank in the two others. So let's dig into why that is. And that's because the custom dimension in these two elements does not contain the attribute called message. So if I were to change this to category, which is present here, I can run this again. And we see now message moved to the end. And we see that these two actually have, because it's the same exception, they have both a category which they can fetch out and present in the output. So this is a way of actually digging out information from within. I could also just do some simple arithmetic in here. I could call this my funny column and say that this is severity level times 3. And now we'll get rid of custom dimensions. So now I'm extending my output of my query with this funny column. And as we can see, the input is severity level times 3, which is correct, 9. So I can do all kinds of string arithmetic, math. There's almost no limit to what you can do in these extension functions. All right. So I could also say that I actually wanted to maybe get rid of the timestamp. I'm not really into the timestamp, and I want to summarize. Now we're diving into some of the more advanced part of KQL, not just selecting what is there, but actually manipulating the data to fit our needs for reporting or for analytics. So I could summarize this, and I can say maybe I want the sum of severity level by method. Maybe sum is not the proper, and this is maybe not so fitting in this example, but it's just to show you that you can also do all kinds of summarizations, aggregations on top of data that you want, and have it reported out in in your query result. I can then sometimes think, okay, so let's see if we say 10 days. Are there any, okay, maybe we should filter out these nans or maybe go with something else. Let's see if we can build this with custom metrics. So let's see some custom metrics for the last, for the last 30 minutes. These are some of the custom metrics within our test environment. So we can see that we have at some point here had 7 tabular processes. So we are processing 7 models. This is the indicator of that. So let's just say that we want to say that it has to include tabular process. Now we can see that the value kind of changes. And if we were to summarize average value by, what's it called, name. So now it's a proper average value. But we could also visualize this in a chart. So in the bottom of our query pane, we see one pane called results and one called charts. In the chart, it's configured to standard show a column chart, and we can change that in our chart formatting out here in the right menu. So as we can see, the default here is a stacked column. We have timestamp on the x-axis, which is fitting nicely, and also the value and split by name. So this means that if we were to, remove this where clause, we would get a number of series in here for each of the services actually putting data into this workspace. I'm not sure the output will be very viewable. Let's do that. But you may notice that when I run the query again, it's not defaulting to chart, but defaulting to results. And we can actually help by extending that into the query. Because there's a, caps lock. There's a query extension called render and column chart. So now it's rendering column chart. So we're back to where we were before. We could say we wanted a line chart, but it's ugly. So we'll stick with the stacked column chart. If we wanted to exclude this where clause, we can do that. And let's see if there's anything remotely visible in here. But as you might guess, these charts are not really, well, when data is not beautiful, charts and outputs of that is not beautiful at all also. All right, so now I have something that I want to present. I've worked tirelessly night and day on my very, very complicated KQL query. And I want to share that with someone else in the organization. Then you have a number of options. Up here, there's firstly an export option. There's a share option, and there's also a new alert rule. Let's take that one at a time. In the export, I can export to CSV all columns or displayed columns. I can open in Excel. I don't, as a BI professional, really like that. I can open in Power Query or in Power BI as an M query. I like that very much. And I can open in Power BI as a new data set. And that's a new addition to the options which has come to lately. I will go through the Power BI as an M query because then it's kind of visible to you what actually really happens. So when I click that, there's a little file generated for me, Power BI query text. And this is the same name for all of the queries that I generate. And now it's gone. So we'll just create it again. And when I open that up, I get a file containing some comments on top. I could get rid of that, but it's actually a description on how to use this query. As you can see, in Power BI Desktop, select Get Data, Blank Query, and the Advanced Query Editor. And then you can just paste this entire script in. And if I do so, open up Power BI Desktop, I can open up a new query or a blank query within in Power BI, and I can then paste in this result just to get the Power BI ready for you here. And in Get Data, I can select the blank query option down here. And if I do so, I will have the option to actually, paste in that query in the advanced editor up here. And this is where we can manipulate the Power Query language that Power BI sources its data using that Power Query. But we can actually see some of the KQL behind the scene in here. We can see custom metrics. We can actually see the entire KQL statement up here. And we can also see there's a duration set. We set it to 4 hours. So that's something that we set in the portal. So it's now a part of the query that is run against application insights. So I need to obviously authorize. I have my organizational account. I'm going to sign in. Let me see if I can. Obviously, it's not the right one. And now we have the query result within Power BI, and we can do all kinds of stuff that we can do in Power BI with the data. So now it's loading these rows into the model in Power BI. Obviously 15 rows, it's not taking much time. And naming and so on is not really, well, we haven't worked on that. So as you can see, we have the query resulting in this query output, and we can then drag these in and report on top of that. So that's just to show you that you can actually connect it in to Power BI. The other option is to share. You can copy a link to the query, so you can actually have someone link directly into the query. I can copy the query text, or I can copy the results. Besides the link, the other two are kind of a static output of this, and not really recommended unless you want to pinpoint something in particular. The one that we didn't highlight earlier was the pin to. It has moved around, but the pin to is actually the one that I'm really keen about. You can actually pin this query to a dashboard within Azure. So now if I select that I want this to be present on an Azure dashboard, I can select, is it a private dashboard only viewable for me, or is it a shared dashboard, and in which subscription will it sit, and what's the dashboard called? So let me just create a new dashboard. Like that, and say this is the Virtual Azure Community dashboard. And I want it sitting, yes, in this one. Oh, yes, dashboards. And now I click create and pin. So I create the dashboard since it's not created already, and I pin this visualization to that dashboard. So creation succeeded, successfully pinned to the new shared dashboard. And if I'm not mistaken, if I click on the link, I will be taken to the dashboard and I can see the result of my query. So now you notice that the result is different. And that's because you have some options in the dashboard. You need to look for the auto refresh. It's off, so you need to manually select refresh here to refresh the query output. And you can also see that the time span is the past 24 hours. We set 4 hours in the query, and we can actually manage that in here in the dashboard. So if we customize this, we can make it bigger, smaller, and we can configure the tile settings. And this is one of the more important options, time settings. Override the dashboard time setting at the tile level. So if we select that, we can specify a time frame for this visual only, or this tile. So if we apply this, it will be only for the last 4 hours, even though the dashboard says 24 hours up here. So that's something you need to be aware of. There may be some differences between these two. Just when you kind of read the output or the visualizations, you need to be aware of that. All right, so let's get back to the query. And sometimes you get back in and you can see that there's a query history kept for you. So I could select one of the queries that I've run earlier to actually expand on my explanation here. So now if I'm running this for the last 12 hours, maybe let's just say 4 hours, like this. It's doing something odd. It's because this one is stuck up there. Usually KQL would barf if there were multiple queries in here, but it's actually just showing the first one. So now I should get a completely different chart. I now have 4 queries joined into one, so to speak. So we're still looking at custom metrics. And initially I'm selecting where the name is incoming source data. So when we receive data from our clients, we register that in incoming source data. We order that by timestamp descending, and then we summarize that as files in queue. So this is queue events in the Azure storage queues in this particular incoming source data queue. And if you notice out here, I want the max value by hour, and I want it binned by time span, the timestamp in 1 hour buckets. So for every hour, I'm looking up the maximum value. What's the maximum number of files we received in that time span, last 4 hours. We can see here files in queue is the blue one. We're dwindling down, so to speak, on Wednesday. Usually it's Monday midday to Wednesday midday we get all of the files. But the next one we then join to that result is a query against custom metrics again. So the same metrics we're querying, the same table, but this time we're querying tabular process. And this is what we call models in queue. So these are queued for processing, and you can see we join on hour. So the output of this is an hour, as you can see down here below. The hour 11, the hour 12, 1 p.m., and so on. And then we have a max of the value in that hour, past hour. So we do that for 4 different queues within our storage account. One called incoming source data, tabular process, published to data mart, and source data retry. So if there was any errors in the first runs of these data that we received, it will attempt a retry. And if that retry continues, we then have alerts to notify us about that. Because that's the next step. So you can see here, this is nicely rendered as a column chart with hour and the maximum files in queue, maximum retries in queue, maximum data marts in queue, and maximum models in queue. So we can actually see the pressure on the system from ingesting data to actually serving it up in the analysis services models to our clients. And this is obviously just a 4-hour scope. If we look at this for the past 7 days, you see a different picture. You see that during weekends, there's not much activity, but during the last 3 days, maybe, let's just stick with that. We can see that there's been hefty activity. This is Monday, midday, afternoon, Tuesday, and then Wednesday dwindling down. So constantly we're processing analysis services models because of master data changes as well. So that's kind of a constant for us that we're processing models. That's one example of some of the more advanced analytics that we do on top of our, basic data. So this is a number of messages in a storage queue that we turn into this kind of information. KQL is capable of very sophisticated time series calculations and so on, and we are not even close to using or taking in the breadth of that language. I hope we will dive more into it in Catman, but yeah, let's see. We're happy with Gusto as it is, and we have a couple of SQL guys that kind of it's not like I used to see it, and why is there's no select, and there's always arguments towards change, but in my opinion they have heard some of the needs and wants of former query languages and actually built that in for something that the developers can actually use. The final thing that I'm going to use or display is the alerts. So this is a way of actually having the system work for you. So now we created a query. If we want to look into the results, we can do that. So we can see that, okay, at some point, if like this, there's 10 data marts in queue, I want to be notified about that. I can create a new alert rule, and it automatically copies the query that I have run. And so I can specify what I want to measure. So depending on the output of the query that we have run, you have various options in your measure here. So I wanted to be notified when this specific measure data marts in queue and the maximum of that over a period of 5 minutes. Let's say is greater than, and let's say 10, and I want to evaluate that every 5 minutes. So every 5 minutes, I want to look into my queue length, so to speak, and see if it supersedes my threshold value. If it does so, I want to actually create an action group and notify those. We can see that in a minute. As you can see here, this is a kind of a preview, and it's not always very good. But one thing that I want to emphasize is this estimated monthly cost, $1.50 for an alert that works for you every 5 minutes. Well, yeah, you can't do that with manual labor, right? So if I go next to the actions, I can select an action group, or I can create an action group. And this is, in sense, a group of people that you want to be notified with this alert group. We have a number of alert groups within the organization, something about budgeting, something about migration, tabular response team. Yeah, maybe we could take those just for, no, well, we'll create a new one. So I create an action group, which takes me to a different scenario. It needs to have a resource group, a region. Where do we want it put? This is a Virtual Academy Community Day group. And this is the display name. So when I pick that up, I go to notifications and I pick the notification type. So is it resource manager role, or is it email, text message, push, or voice? And this is, let's call it Jens. And I want an email with that. I could also, if I want a text, they used to have Pager in here, but I see that that's out now. But I can also have the Azure mobile app notification. And if I link the account email, I can be notified using the Azure app. I click OK. I call that Jens. That's because it's me. And then I get to select the action type. If I want anything to be fired, an Azure function, a runbook, some webhook, you could create a ticket in your ticketing system or something like that. That's also possible on top of an alert. And obviously, you should tag your resources. So this is me owning it, and it's state presentation. Now I review all of these selections and I click create. And now this Virtual Azure Community Day group is present in my actions part. I go to details. And this is what you will see in your email message. And there's one of the shortcomings of this, because it's not something you can change after you create the alert. Then you'll have to delete the alert and create a new one. So just type in something, and yeah, North Europe, that's perfectly fine. We'll not go into advanced options, just again, tag your resources, state presentation, and review and create. So this is going to cost me a whooping $1.50, and I create that. And every time my data marts and queue supersedes the number 10 within a 5-minute span during the last hour, I will get a notification. So this way, I've made this query run for me, work for me tirelessly round the clock, and for a measly $1.50. Obviously, if you get a lot of data, the price is not $1.50, but in this case, counting the number of files that are roughly somewhere around 2,500 to 3,000 files per week, this is very overseeable. All right, Sherry, are there any questions that we might take?
Not really, as far as I can see in the chat. So for those of you who are reaching us, if you have any question for Jens, please write it down. I will bring it to him.
Yes. So I can do some other examples. Do we need to? I mean, it's past my 4 o'clock. How strictly are you?
If you want to show another example, just go ahead.
Okay, I can show you one more example. So this is some maybe more into detail. So currently we looked at the overall pressure on the system. So files in queue, retries in queue, data marts in queue, and models in queue. What happens when we receive a file and file load, mechanics behind the scene? So I click to open a new query, and I've prepared one in here. This, as you can see, has some more extensive KQL to it. First off, I'm filtering timestamp. I only need the recent 2 weeks. We always compare week on week. And then I select from the custom events timestamp. And as you can see here, the custom dimensions, channel item ID, function, job execution ID, timestamp, and message. Then I filter. If I do nothing else, this will translate into this kind of naming convention. So custom dot function will become custom dimensions underscore function. So this is the way that this resolves in the query and the code completion later on. And I know that the function I'm looking for is mail reader process channels, channel items, and the custom dimension function process channel items for the FTP reader. So currently we're looking at both files that we receive through mail and through an FTP instance. I also want the message to contain the text load file. So the message within this custom dimension needs to contain load file. I then summarize the previous 7 days and compare that with the last 7 days. This is to show kind of a week-on-week comparison of the numbers. So you can see that the two calculations here are different. More than 7 days old and less than 7 days old. That's the kind of notion that I want here. And then I need to find the weekday, and obviously there's some mix up between what is the weekday in Denmark and what is the weekday, the start weekday in Denmark and US, and that's different. So I need a conversion of that, and unfortunately I need to do that like this. But once you see the query result, you will see the meaning why. So we can see that we have files loaded for Monday, Wednesday, and Thursday. There's no files on Tuesday, and no files on the other days, just these days. Last Monday, we received 0 files, but the Monday before that, 677. And this today, we received 10, and last Wednesday, we received 0, and so on. So this is a way of actually comparing week over week, and I can do that, it's me deciding that this is a 7-day period that I want to aggregate. So if that were any different, we can do that in the calculation as we see. And this is where Kusto or KQL is very configurable. We've had clients that are running on telemetry data where they have dashboards that go instantly from minutes of reporting into years, full 5 years of aggregating data. Obviously, they sit on ADX and not in Azure Monitor, but that's just the power that this query language was built for. So it's very, very powerful if you get the instance behind. And I believe, if I'm not mistaken, there's a free instance of ADX that you can spin up and you can play around. There's also a demo site for playing around with some storm weather data, shark attacks, I believe. Also, you can query, and I might also throw in the Kusto detective link, which is this one. So if you go to detective.kusto.io, you can become a Kusto detective. And this is where the system takes you gently through some Kusto challenges, and you can earn badges, and you can compete with your peers who has the highest level and so on. And meanwhile, you will be learning Kusto. So that's a nice trick by the team behind to do that. I think that was the end of my presentation. If you have any questions that we're not addressing here, please reach out. You can find me on Mastodon, LinkedIn, and email. So don't be shy. Don't be a stranger if you have some queries, even outside Kusto, and I'm open to discussion. So Sherry, thank you for having me today. I'm super annoyed that I couldn't be with you tonight. I have a young lady at home that is seeking higher education, and I need to support her in that. So I'm unfortunately tied up elsewhere tonight.
Yeah. Hopefully we meet soon somewhere else. And thank you very much for this deep dive in Kusto. I have one thing. I didn't see any question in the chat. But there was a question not about your presentation, but about the Azure Heroes that I shared the link. So I might need to share my screen for a few minutes here. People, the one that they already had Azure Heroes before, they couldn't actually use my presentation. They couldn't use the link. So they please scan this QR code if you want to get Azure Heroes and you already have some badges. The link that I shared, it directly goes to the Custo, sorry, not Custo, a little bit distracted. It goes to the web, actually web wallet. So this one is going to go to your current wallet if you already have Azure Heroes. And thank you very much for all of you that you stayed with us for the day. I am very late. Need to get back to the venue to kickstart the next session with Morten and Azure Community. So if you're in Copenhagen, come and join us. Otherwise, we will be back online here on the same link around 6:30, I believe. So thank you, everybody, and see you all later.
Yeah,
Bye.
thank you. Bye-bye.
is a person who wrote the first line of Templify. And today he is the CTO of Templify. And he's going to tell us that how in Templify they actually use set up their DevOps environment and using all the services that they have. So he's going to give us like a deep dive on how Templify literally works today. And stage is yours, and thank you.
Thank you. So welcome everyone. This is a dual event, so there's someone watching online. This is a streamed event, and for those online, there's a whole crowd in front of me. So, but I will pretend you are not there online. But hello to all of you. So, as Sari said, I'm Thomas, and I'm CTO in Templify. And I think the title of my talk was how we do 30 production deployments daily in Templify. And I also promised it will be a very demo-heavy presentation, but I will set the stage. So the first 15 minutes or so, you will have to bear with some PowerPoint slides, but then I do promise that you will get to see how we built all of this. So let's see if we can get this working. So again, setting the stage, talking a bit about DevOps, and then demo, and if time permits, Q&A at the end. I know there's also the room for Q&A online. You can ask, but I will not promise we get to answer all the questions online if there's any. But let's see where we go. So setting the stage. So Sherry just said I'm CTO in Templify, and what is Templify? And it's not that I want to bore you, but I'm setting the stage because this is important when you understand why I think it's pretty darn cool that we can do 30 deployments per day. So Templify is solving one of the biggest problems in the business industry for knowledge worker. What is that problem? Well, you all write documents, whether it's Word documents or it's PowerPoint presentation. And the thing is that if you work in a big enterprise, typically there's different kind of stakeholders. On one hand, you have your brand who wants to make sure you use the right font and logos. You have legal who wants to make sure the footer, disclaimer, and phone number is correct. On the other hand, you have your IT department who bought and invested in some good IT system with image banks and so on. And in the middle, you have kind of like yourself, and you just want to create a presentation like the one I have here. So this is in very short, what is Templify doing? And we are automating everything here, integrating and empowering the end user. Cool. So that's the stage. Another part is I just want to show quickly who are some of the customers of ours. I'm pretty sure you know a logo or two of what's up here. And since this is our product is typically running inside Word, PowerPoint, Excel, we typically roll out enterprise-wide. And I think there's at least 5, maybe even 10 of these customers who have more than 100,000 users, and we install our software on the desktop. That's setting the stage why 30 production deployments per day is kind of like a scary thing, because when we talk to these people and they hear that, they take 2 steps back and say, that sounds insecure, that can't be safe, it's probably failing all the time, and no, we are not going to buy it. Yet, since they bought it, it's kind of like a testimonial that this is kind of like a good way. And what I want to prove to you today, or hope at least your takeaway, is that this is a safe way to operate. And please pay attention to there's highly regulated industries here: healthcare, finance, insurance, and so on. It's not just your mother's company in the basement. Cool. So I also want to talk about DevOps, because you might be wondering, why am I talking about 30 production deployments per day? Why is that an interesting number? And I want to kind of like make sure why I think even as a CTO that is a good number to look at when I talk to my engineer and I tell them how we should work. So if I were to ask 100 people what is DevOps, I would probably get 100 different answers. But as there's a lot of books written about DevOps, and there's also an acronym called CARMS. And it's most of you think about DevOps, it's about automation, it's CI/CD, unit test, and deployment. But if you do 30 deployments per day, you have to get it into the culture. You have to get people to understand why is that a good way of working and actually embrace that way of working. So yes, there is a lot of automation, but also when you have a lot of teams, they need to share knowledge. And talking about teams, also just setting the stage, Templafy is around about 300 employees. Of those, 75 are engineers, and then we have some product people. We have 12 teams. We have 8 product teams that ship the modules that our customers buy, and then we have 4 platform teams. The SRE team or the DevOps team, we call them SREs, are one of the platform teams. So there's a lot of sharing between these teams, and I will show you in my demo what one of these teams are, how they do a deployment. But I could have picked any team. I actually just picked a random team because they all share how they're doing and they all share the practices, and we have to have quite a lot of operational consistency. So what I show you here applies almost to all my teams. Okay, another thing I just want to talk slightly about before I move on and go into the demo mode is, how many of you have read or heard about this book? Yeah, surprisingly few. And this is probably the most influential book written in our industry, if you ask me, because this book is based on the biggest study in our industry, which has been running since 2012. It's known as State of DevOps. And it's Nicole Fosgren who wrote this book. And it's actually a scientific study of how does software team works. And what they set out to do was, when they made this, was to kind of find out if we could have some measures that could be predictors of whether you are a high-performing or even an elite team, or if you're a low-performing team. And the important part here is a high-performing team is not by definition someone who ships a lot of things. A high-performing team in this study is teams that reach the business goal or go above. That means their stock price go up, and if it's inside and you compare one team to another, it's teams that delivers the value to the customer. So this is based on this classification on high performer versus low performer is based on business metric, not engineering metrics. And what the State of DevOps set out to do was to ask a bunch of software people working with software, and they've been asking tens of thousands of people every single year since 2012 about, do you use version control, do you use CI/CD, do you use public cloud, do you use infrastructure as code, do you use static code analysis, so on and so forth, a bunch of questions. And then they kind of like, okay, they tried to figure out, are there some measures statistically that can predict whether you are a high-performing team? And they did find such measures. They actually found 4 metrics that are predictive of whether you are a high-performing team. It doesn't mean that if you are good in those metrics that then you are a success. They are a prediction of whether you would be a success. So the first 2 metrics I want to highlight is deployment frequency. 30 times deploying to production per day. So I think it's fair to say that if you look at these number, elite performers, they deploy on demand multiple times per day. So I can quite comfortably say we are in that category. And if you look at the low performers, still running some kind of waterfall fewer than once every 6 months, you know, there's a huge difference. Now, if you deploy 30 times per day, it's not really good if it takes 3 hours to do a deployment, and there's a lot of manual steps. So the lead time is also very important. That means from the time you commit code into a code repository until the code is running on production. That's very important. And as you can see here, the elite performers is less than 1 hour. And again, the low performers, since they only deploy every 6 months, you know, from committing code, on average, it takes 6 months to go to production. On that measure, I think we can deploy, and we often do deploy. I'm sure that maybe half of the deployments we do every day is with a lead time of 1 hour, but then there's others where it takes a bit longer. And for the Templifiers in this room, this is a number you should focus on, because you all heard software engineers are in the zone, they're writing code, and you should not disturb. And as I will show you, we do pull request and we do review. And when I have my pull request and I'm ready to deploy, I have this guy sitting next to him and he's in the zone. I should not disturb him, should I? I should, and that's the point. Because if I can disturb the guy next to me, say, could you please give me a review? He will get disturbed, but I will not. I can continue in my zone and get my thing ship to production so I can go to the next thing. And when he asks for a code review, it's my turn to be disturbed. So that means if you strictly follow this rule, and I know we are not machines, but if you were to follow that thing, no one would ever work on have more than one thing active at a time. And that's what we're trying to do. That's coming from lean and the theory of constraint and minimizing work in progress, all those fancy words that we learned to love with agile and lean and so on. So it's a good thing to disturb an engineer to help if that means that you can get unblocked. And we talk so much about unblock others before you do things. Okay, so we ship a lot of time and we do it fast. That's all great. It sounds dangerous, yes. So the two other metrics that's in the DORA report, and I actually forgot to mention what are DORA. So, okay, I'll just take a step back. So I talked about the state of DevOps, I think 2 or 3 years ago. It's that study split into two. There's still the state of DevOps, and then Google bought DORA. It's the DevOps DO research assessment, and it's run by Google. So they're called the DORA mix. But this is you can read both reports every year, and they kind of like conclude the same. Yeah. So there's two other metrics because we move fast. The two other metrics are kind of to ensure that we move fast without breaking things. I know Facebook said move fast, break things. I think they changed it, move fast, don't break things. And so the first measure here is change failure rates. From all the deployments you do, how often do they result in an incident where you either have to roll back or fix forward? I will come back to us. We actually never roll back things because we do 30 deployments per day. We know how to do deployments, even in the middle of the night if we were so unlucky. There's something, it's just intrinsic knowledge. We know how to do it. So we always move forward. If we have a database, you do a deployment, you add a new field and set it to not null, and it's all good, then you roll back, and then it's just really hard to roll back things because you don't know the state of things. So we never roll back. If you see the low performers, well, they have a change failure rate of 16 to 30%, and the high performers 0 to 15. And to be honest, I'm a bit puzzled about that specific number, because if we had 10% failure rate, that means we would have 3 incidents per day. I can promise you we don't. So we are actually well below 1% change failure rate. So there's some things when you take them to the extreme, then the numbers really don't add up. And then, of course, the mean time to recover, that means how long time does it take when you do have an incident until you have it fixed on production? And this is a scary number. It takes them 6 months to fix a production incident. I don't know what kind of production incidents, but they have. But yeah, I mean, there's different rates. So again, I'm not an expert on this, so take them with a grain of salt. Again, we can fix a production incident in less than an hour, and we often do. But since we always roll forward, that means that if we are going to fix a production incident that involves code, we have to do a code commit, we have to do the pull request and so on. I will show you all that. And from us detecting an incident, fixing it and going through that, it does often take more than an hour. And I'm saying to my team, we do it. Some say, shouldn't we just skip the test because we're in a hurry? Like, well, now is the time to lean on your test. So we don't do that, but we are working quite hard to minimize the time, the minimum time it takes to get something from code commit to production, the technical time, not the people time. So, but I will come back and show you all of that. So that was only 14 minutes. I have a watch here, so I'm kind of on my schedule here. Now I have to put my glasses on because otherwise it won't really work. So what I have here, and I trust you can see in the back because I tested it, and I know it might be a slightly blurry online, but I also know that you can read it. So what I have here is the dashboard that you can see on the big screens, and now it's after 6 o'clock, so it actually just closed our dashboard. But for those of you who were here early, you have seen this dashboard at the end here. And what it shows is kind of like a high-level status of the different teams we have. So we can see how many stories are in the current sprint. We have a 2-week cycle. My team can run Kanban or Scrum. I don't really care because we ship multiple times a day. It's not like we have commitments for sprint. It's like things are just flowing over. So most teams are running some kind of flavor of Kanban. The other thing you can see up here, well, I should use my mouse, so what you can see up here is that the average response time of every request on our website is in the low, around 20 milliseconds, so it's pretty fast, but that's just show-off numbers. We peak at 10,000 requests per second, so that's also pretty good. You can see in the middle, you see this list of all the bugs that we have reported, had active over the past year or so it's somewhere between 25 and 40, or yeah. So quite few bugs. I'll come back to that in just a second. Then you can see the number of active features. So we have every feature stories, and we try to minimize work in progress. So you can see that every single column here represents one of the 12 teams I have, and there's only 2 teams who have more than 2 active features they're working on, typically because they're in a transition from one feature closing down to another, just need to wrap up a thing or 2 before they move on. If I go down a bit further, you can see things like how many stories. I know it's vanity metrics. I don't really care, but it's fun to see that, on average, we ship 50 stories per sprint every second week, and the lead time is 12 days, which I think is fairly high. And to be honest, I shouldn't micromanage, but I'm like, okay, you need to work smaller increments. You can also see the number of bugs, also lead time of 10. And if I were to go 1 year back, the average time to fix a bug was actually 5 days. So that's a number that went in a wrong direction. Then at the bottom here, you can see we have currently 27 bugs open. And you heard that right. 27 bugs, known bugs in our system. And of those 27 bugs, only 3 are currently reported by customers. So we have a zero defect mindset. I know this is kind of like something that people say, yeah, that's good, but we prioritize our bug because we cannot just fix them. But it took a very long time to get that to that level. But now we are there. And if you do so many production deployments, you really need to take special care of all these small hints that something might be wrong. You get a bug report that XYZ is failing, but it turns out the underlying reasoning is something bigger. So a bug report is something that teams, as soon as they get them, they investigate, okay, what is this, just to make sure it's not really an incident. And then next time they start a new pull request, they start on that bug report. I mean, give and take. It's not like, again, we're not machines, but most teams have a tech trooper. But if you kind of like, maybe I should zoom a bit here. If you can see here, there's a created column. So just today, there was 5 of those 27 bugs are reported today. And you can see 2 of them are already resolved. I will come back to that in a second, why they're not shipped yet. And if you go back to, here's down to the December and then November, then we only have 2 bugs here at the bottom that is more than 3 months old. So, and even though I'm talking here, I'm also saying these bugs might not be affecting customers. It could be a failed build. It could be something behind a feature flag. It's something we didn't even ship. So we have a really broad view of what is a bug. So again, some would say we are too much focused on that, but it's in our culture, coming back to the CARMS principle. Okay, so that's our dashboard. What I will do for the rest of the demo is kind of like show you how do we take something from code commit all the way to production. And as you already seen, this is our live thing, and our InfoSec is on board with this. I checked it out, and since we have this regulated things, and I'm so confident I'm not showing you something that you are not allowed to see. But it is a leap of faith, because I'm not 100% sure what's there. But yeah, let's. Okay, so what I have here. Okay, so let me just give a quick overview of DevOps, Azure DevOps, because most of you will say, "Oh, GitHub is the new thing. It's the new kid in the town," and so on. And GitHub is great. I haven't personally used it in Simplify, but I talked to a lot of Microsoft people and say GitHub is great. But when it comes to so GitHub is definitely superior when it comes to pull request and code management. When it comes to the build pipelines, GitHub Actions, I'm told, I don't know, so don't take my word for it, that DevOps still have something to offer where GitHub has some catching up to do. I'm sure there's something the other way around, but what DevOps truly shines is the integration with what they call boards, or the backlog and the work items and bugs and tasks and so on. And this whole integrated experience in one tool, and you can see them out here. So you have your boards with your backlog, and I'm showing you a sprint board here. I can make all kind of queries. I have my repositories which is Git repositories and pull requests, and I have my pipelines, and there's also some artifacts like NuGet packages and an npm package, all in one tool with single sign-on, and it just works. I'm not saying this is better than DevOps, than GitHub or GitLab or whatever. I'm just saying I'm very excited about this. That's the takeaway. I really like this. And if you think that there's a better tool, I always ask my new engineers, what are you doing in your previous workplace that we're not doing that we could do? And then we are all over it. We have 2 days every sprint, the last 2 days, which we call tech time. It's not Google 20% time, where engineers can do whatever they want. So that's why we do a lot of the cool things that I'm going to show you. Anyway, back on track. So I have here a story. It's a small one. It doesn't really matter what it is. It's not the point. And there's a task. Okay, again, doesn't really matter. But I'll open this task. And you can see there's, of course, a creation date. I can see it's created by Thiago. I can also see it was created the 4th of January. And as you can see here at the bottom, we have a bot that every time we move to a new sprint, we have a bot that manually moves tasks from one sprint to the next. So we don't have active or unclosed stuff in old tasks. It's a feature which strangely is not in DevOps. So we build it ourselves. No problem. There's a phone going off here. So I want to kind of like focus on this area down here to the right. It's called development. And what you can see behind this task, there is a commit, there is a pull request, and there's a couple of builds. And I will click on the pull request here, and I will go to our pull request experience. And at a glance, you can see that, okay, it looks like it's been reviewed and so on. But before I kind of like go in and show you the details, let's just look at what is changed. So, okay, it looks like 3 files are changed. It's an API controller. I believe most of you are working with .NET. So it's very, this is the entire file. That's an endpoint that's using an existing asset service to get something called asset. Doesn't really matter here. And obviously, there's some unit tests that test that this work as expected, and there's DGO being returned. The takeaway here is it's not a big thing. It's something I can keep in my head. So what you say, there's this saying, if you make a pull request and there's 1,000 lines of code, you get 0 comments. If you make a pull request with 1 line of code, you get 1 comment. Because people cannot comprehend big things. So we do such small things. And the other takeaway is, now I know you're probably not engineers or software programmers, all of you, but that didn't look that dangerous to ship, did it? It compiles, it doesn't break anything. It doesn't add any features either, because it was a private endpoint that could be called from a web UI, but there was nothing in the web UI. So I'm shipping something that doesn't add any functionality, but I am shipping something to production that runs in production and doesn't break production. And if it breaks production, I'll just, we've deployed this and it made it fail. I wonder what thing went wrong. It's very easy to figure out what caused that incident instead of, the bi-weekly ship where you take like 20 stories and 20 pull requests. And not only that, even if you could after 2 weeks find, oh, that's the thing, you might have had a front end that was built on that and another thing that was removed. So now it's not just rolling back, it's actually hard to fix. This one, if this causes a production incident, it's really easy for me to just remove the code, do a reverse commit, deploy it again. It's not always like that, but we take these very, very tiny steps. Cool. But you say, what about security? What about all these things? So that's the second thing I want to show you about the pull request. So you can see here, there's 7 checks that runs every time we do a pull request. And I have them here. At the top, we have our build. Of course, the code is built. So let's click into that. And you can see that, there was a 100% code test. All the tests succeeded. of this new code, there was 92% code coverage. You'll say, I'm just cheating, but I'll come back to that. It took 12 minutes, and it's actually, I normally it takes 6 to 7 minutes for this particular build. But let's see what actually took this long. So I can see here, I can go into the build and I can double click or drill down. I can see all the things that happen, and you can see there's a lot of things happen. And if I go here, you see, oh, code analysis took 11 minutes and 45 seconds. I'll come back to the code analysis in just a bit, but it's some static code analysis, and it shouldn't take that long, and normally doesn't. But you will also see if you add up all these numbers, you get more than the 12 minutes. That's because all these things runs in parallel. So yes, we have a lot of build servers, and my CFO is saying, could you save some money on that? And well, I'm like a bit reluctant. I want to save money because I don't just want to fire off a lot of Azure resources, but on the other hand, it's really important for me that we can work this way. So it's a trade-off, if you want. I want to maybe just talk slightly about this one, resharper lending. How many is actually software engineers here? More than half, or half, I would say. Do you use any kind of like static code analysis tools? Yeah. So we have resharper. We are writing C#, and you can in C# you have constructors and properties and methods and so on. We have convention that says properties goes after the constructors and then comes the method. If someone were to do it differently, that would fail. I mean, they get the warning in the IDE, but if they try to commit it anyway, it fails the build. The same as they have two spaces between, or no spaces between method, it fails the build. If they use types instead of var, it fails the build. So it's pretty annoying when you start learning it, but then when you get into it and there's like a control EF in resharper or writer, then you just do it. And that means when you go and look at a code base, it looks like, it's just pretty and it's clean and so on. Of course, not everything, but in the methods is clean. That's up to the software engineer, but the overall part is pretty clean. So, okay, so that was the thing about resharper lending. There's other things I could deep dive into, but let's not. So, okay, so I have my build running and unit tests are running, and all this thing is fine. Next, I would love to kind of like do some end-to-end testing. And I think this is a place, okay, so I'll go in here and click on the end-to-end testing. So what happens is that we run end-to-end testing before we merge to master. How many of you is doing that? There's one and two. Okay, so two and a half, 3-ish out of, I don't know, 30, 40 people. So what we do is that we have a Kubernetes cluster with, it's fairly big, and there's multiple environments. I think there's like 20, 30, 40 Kubernetes environments running. I'm looking at my, so he's not confirming anything. But anyway, too many and too expensive. But again, I think it's worth it because that means that we can run end-to-end tests before we merge down. That means that we're pretty sure we don't break anything. And what you can see, the first thing that's happening here is that we are obtaining a log to this Kubernetes cluster. And then we go in and say, okay, let's deploy all our, so it says here, self-contained system. We are running a microservice architecture, but we have a special flavor of microservice architecture that's called self-contained system. I call them sometimes small monolith. And if I click on, I didn't want to click there. I want to click here. You can see we have, I think, you can count these. That's around 14, 15 services that we deploy. This is Docker containers. Actually, some of them have multiple Docker containers inside. So that's why every single self-contained system have microservice inside. That's why I call them small monoliths. So we have API and background jobs in, for example, our account management or user management. We have both the API and the background jobs in that thing. It makes it extremely easy to develop. But it's a very opinionated thing. I'm not trying to convince you. I'm happy about it. But the interesting thing here is that you see, I'm currently looking at this library management. And you will see that here I'm deploying the Docker image. The Docker images from this pull request, where all the others are what's running on production. That means my feature environment is exactly like production with this change. And that's the thing. And So yes, and some of you would probably say, okay, now, sorry, I'll just go back. Okay, some of you would probably say, you should not test your entire environment. You should just test this single microservices. And then if that works, you trust that everything else is good. And I get that, because that's because what we are doing is so bloody damn hard that most people cannot do it. But we are testing the entire system, including login. And we have, as you see here, we have some smoke tests that can make sure users can log in. We can create what we call a tenant. We can create a document. And then we have a bunch of tests here that is specific to this self-contained system, library management, that we are looking at here, that test that everything in library management works. So they are very, very specific to that. And then we have a lot of API tests that runs for the different kind of API endpoints. So we do a very rough smoke test of the entire system, and then a thorough test of this specific system. And when everything is green, we release the lock, and someone else can guess this feature environment. Cool. So coming back to the pull request, we now have unit tests running, we have end-to-end tests running. Then we have a small little check, which actually should have been before, but doesn't really matter because it never fails. We just make sure that if you have some NuGet packages or npm packages, that you use something from a master branch, not something from a different branch that can contain a security thing. So you cannot hack your way. We had a hackathon at some point where we said, could a single engineer push things to production without getting approval? And people became very creative. So they got the pull request bot to approve the request, and they tried to hack the build servers, inject things, so it picked up something. It's like, it was quite fun and scary, but yeah. Anyway, so that's an outcome of that. Okay, then we have this one, a quality gate. I've been saying static code analysis quite a few times. So what is this? So let's click on that one, and I'll go to a tool called Sonar Cloud. And what you see here is a report from this specific build. Sonar Cloud is a cloud version of an open source tool called SonarCube that does a bunch of things. So it tests for bugs. This is something like, division by zero or dead code or other things that doesn't work. And then it tests for security things. Maybe you're using an MD5 hash, or you're using system.io.files, and there's some security things, so you should use something else. And so it detects it and it warns you. If it finds anything, it makes a comment on the pull request. People don't have to go here. It says in the code, that line of code there is wrong, go fix it. Then it takes some maintainability things like cyclomatic complexity, too many parameters, or unreadable code. And then it has some security hotspots. It's not that it's insecure, but maybe you are using some cryptographic libraries and so on. Just this thing here, please have an extra pair of eyes on that specific thing. It might be completely fine, but just double check. And as you can see, there's some code coverage. So I just want to go to the entire Sonar Cloud, so you can kind of like see, okay, I said that this pull request from before had 92% code coverage, and it's actually not something that I have been pushing my teams to do, but they all somehow found a way, coming back to the sharing and learning, that having a lot of unit tests for the code is a good thing. So you can see here, 80%, 81%, 80. You go down. There's just continuously just a lot of high code coverage. So the 82% is just average for what we do. You can see out here that there's no of our repositories with any reliability issues, none with security issues, none with security findings, and none with maintainability. And most of our repositories have more than 80%. Okay, disclaimer. I did last week when I was preparing for this session, I saw, there was one little thing there, because SonarCube finds things afterwards. Maybe they detect the thing now and then they start annotating, and we don't get notifications. So most of the teams fixed a few things, just being fully transparent, but it looks good. Yes, all green. I'm happy. Okay, let's see if we can go back to the pull request. Cool. So we have all this running. Cool. Now we come into the more kind of like custom things that we, well, actually this one is easy. There must be a work item related to the pull request. So you cannot ship any code if there's not a work item. And also, of course, all the comments on the pull request must be resolved. So if anyone makes a comment, it can't ship. So the custom thing was this one. We have a field on our task. I can actually go back to here, and so this was the task we had. We had a field called release notes, and you must write release notes, at least 50 characters. And say 50 characters release note, but remember how small this is. This is not huge. So it's a small thing. So a small release note is probably sufficient. Okay, so as you saw, this might take some time to build this and release this, and people won't sit and wait and kind of like watch Azure DevOps. So they will do something else. So I'll just come back because I couldn't really show this real time. But what does happen when someone makes a pull request is that a message is sent out to Slack, and we customize it ourselves. So here I have an example that maybe someone makes a comment on the pull request, and while they're doing that and discussing that, you can see that the code analysis succeeds and the build is going to succeed. And then they discuss some bit further and say this comment is it's okay. So they resolve the comment, and then Mohammed says, okay, I'm okay, I will approve it, and so does Recep, and he also approve it, and then the entire thing is approved. And if you do 30 things, it takes up a lot of space in Slack. So we remove the message from Slack. So if you don't have a message in Slack, it's because you need to do something. If it's just empty like this, all good. You see, I timed this kind of good, yeah. So it's the first time it succeeded, getting the talk track to work with the animation here. Cool. So now we have all this thing running, and we're gonna merge this to master. And what's going to happen then is that the release will start. Okay, so the first thing that will happen in the release is that the build will repeat. It's a step we want to move out because we just built it and now we have to do it again. We haven't really figured out how to do that, but we are working on it. We're using build pipelines for that, and I will just show you. Okay, so this is a build script. It's YAML, and it's great because it's in code. You can push it with the pull request and you have review. And but we actually use release pipelines to release our things. And you say, why do you do that? This YAML thing, that's awesome, it's great. And yes, it is. It's just that there's one feature that doesn't work with YAML pipelines, and that is it only works with release pipelines. And that is that release pipeline can hook up deployments to the work items. So let me go back to the work item, and let's scroll up a bit here. Okay, actually, okay. So at the upper right here, you can see deployments. And what I can see here is that, okay, this work item has been deployed to our QA environment. This work item has been deployed to our staging environment. And this work item, when I say work item, I mean the pull request, the code behind the work item, has been deployed to prod 0, 1, 2, and 3, and 4. I will come back to what these are. But let's go into the release pipeline. So this is our release pipeline. It's almost the same as the YAML pipeline, but unfortunately, when you use them and when you kind of like edit these pipelines, it's not YAML. It's pointy, clicky, and it's really hard to have version control. So my SRE over there is definitely not happy about this part, but he haven't convinced me yet to get rid of it, because our InfoSec and our customers really like this transparency that you can start on a release, on a pull request, on a work item. It doesn't really matter. You can connect all the dots, and as you can see, it's pretty streamlined. It's what we do on all systems, so it's really good. Okay, so back to the release pipeline. The first thing that's happened is that we deploy to QA. Before we deploy to QA, there's kind of like a pre-deployment gate that just makes sure that the work item has the correct state. So I didn't really show you that, but I'm talking about this work item. It started over here, then it moved to active, then to code review. Well, it was in pull request. As soon as we merged the pull request, it was automatically moved to resolve. That's part of DevOps. It's nothing we did. And I will show you in a bit that when we push it to production, it will automatically be moved to closed. Cool. So okay, here. Okay, so there's a check that the work item has the correct state. Now, then we run the the smoke test again. Remember, there was kind of three types of tests. We run the smoke test just one more time to make sure we didn't break anything before we move to QA. And I could go in here and I can kind of like clear all the things, and I can see all the things that happened. But I actually want to just take a failed build, a failed release, because when we have a failed release, you can see here I have an example where one test failed. I can go in here and I can click on it and I can go to attachments. You have to know your way around here, and I can kind of like see, oh, here's a screenshot of what failed. And okay, I'm still not sure what that is. Could you please give me a bit more information? So then I can say, okay, there's a MP4 file. I will just download that file, and then there's a full recording of what happened in the end-to-end test. So you can see here that it's doing a bunch of things. It's navigating our UI, and if I go to the end, oh, that failed. So in the case of failure, you just download this one and say, okay, click, and then they try to reproduce it, and hopefully they can find the same thing on the local environment. And that's kind of like just to help. We're using a tool called Cypress. I know that now we have Playwright and other things, but when we started, Cypress was the cool kit. Selenium has not been cool for many years, but there's a lot of things happening in that space. So that's how a failed release looked like. So let's go back to a more successful release, if I can navigate around here. Okay, so it's running in QA. Nothing manual here. As soon as that succeeds, it's deployed to staging. And staging is our last point of return. That's where we do go in and we do some manual tests. Why? Didn't we just test everything before? Can't we just skip this test? And the thing we are missing to completely just wipe out the staging environment is, if you call back the feature environment, we obtained the log, we deployed, and then we released the log. Let's say we didn't release the log, we just kept the feature environment around, and then we could do all the end-to-end testing there. The feature environment is deployed using infrastructure as code. It's exactly the same as production. We never touched our production environment with any hand, so we trust that our different environments are the same. But it's expensive, and we need to find a good way to make sure that we can have all these feature environments running. But when we do that, we can drop the staging environment and just deploy it directly. So we test all the manual regression testing before that. So there is a approval step that you have to do. And like I did before, there's kind of like, okay, there's a message posted to Slack, and you can see it's deployed to QA and staging. Then you go up and you kind of like click on approve. And after a few seconds, it turns green, and then it deploys, and the message removes from Slack, so we don't have any noise in Slack. Okay, that one I didn't time as well, so I won't. It's going to disappear in a bit. Oh, there. Cool. So another thing is that we don't deploy after 3 o'clock. So, you know, I'm an engineer. I'm working on something. I've been working for this for a day or maybe 2 days, God forbid, and it's 5 o'clock, and my partner, wife, girlfriend, whatever, is waiting at home and wants to see the Netflix, and I'll just, grab my friend and get my pull request, and I'll submerge, and I'm out the door. What happens? 1 hour later, someone discovers that it failed. So we want our people to be around when there's an incident, the software engineers that wrote the code. So it's very counterintuitive. We only deploy between 9 and 3 o'clock, where everyone else is deploying after 6 o'clock and before 9 o'clock. So we kind of like turned it upside down. And yes, we do deploy on Fridays because we trust this. We don't deploy on weekends. So if you make a pull request and you merge it down to master, it's going to roll all the way out to staging. And then if it's after 3 o'clock, if it's before 3 o'clock and you approve, it goes to production. If it's after 3 o'clock, it waits until the next morning. And if you look very closely on the times here, so this went to staging at 11:64, that's before noon. And 6 minutes later, you see they didn't do a lot of regression testing. So 6 minutes later, it went to production. Cool. So one thing that I said with these release pipeline, one of the benefits was that there's this integration to the work item. So I can click on the QA environment and I can see, oh, here's the work item, and it's the same on staging. And I can go to Prod 0 and you can see, oh, here's the work item. So this small thing that I did is deployed all the way to production. Prod 0. So we have different deployment rings that we deploy to. So Prod 0 is the first one. It's real customers. It has 2% of all the load, our own customer, our partner, and let's face it, our small, non-strategic European customers are running on this one. It's not because it's less safe. It's just that we want to postpone rolling out to all the others if we could catch it before. But if you look again at the time, you'll see that this was the 9th, and we rolled out to Prod 1 the 10th. At 7:51, then half hour later to Prod 2, half hour later to Prod 3, and half hour later to Prod 4. So within somewhere between 18 and 24 hours, we have rolled it out to all the environments. And some of you will say, well, when we do that, why don't we just wait a week to roll out here? Because then we feel safe. But the thing is, how do you then do a hotfix? Because maybe the thing you released on Wednesday was to fail, but you did 5 other. How do you do a hotfix? So we don't do all these exercises. We trust our release pipeline. So if we have an incident that's also affecting Prod 1, 2, 3, 4, 5, or we don't have 5 yet, then we roll it out to all the different environments right away. And it's only the SRE team that has the power to kind of like override that. Normal software engineers cannot do that. But that also means that I just showed you that there was one work item on Prod 1. But if I were to, on Prod 0, if I were to go to Prod 1, because we batched up, what you will see is that here's a bunch of things. So when we deploy to Prod 1, 2, 3, 4, there's a lot of things that we deploy to these environments. Cool. What else? Well, just for the record or for the fun of it, so Prod 0 and 1 is running in Europe. Prod 2 is US, Prod 3 is Australia, and Prod 4 is Canada, and we are talking about spinning up other clusters. In the beginning, we were a bit reluctant because there's all this, did we feel safe maintaining it, and what about the cost and so on? But we are at a point now where if we were to get a customer from any other region, they will just spin up a cluster because it's all infrastructure as code. There is some manual things where I have, for instance, to go in here manually and add a 5th one, but I had an SRE who said it took 6 hours to set up. It takes a bit more because that was, yeah. But that's that order of magnitude. It doesn't take weeks or months to set up a new cluster, and we're literally just waiting for the next opportunity to spin up a cluster in a different region. Okay, cool. What did I forget? So I promised you one thing. And that was something about incident management. I've talked a lot about that. And wouldn't it be fun to see how we handle such things? First of all, I want to show you a tool called PagerDuty. If you are doing anything in this, you probably know this tool. If not, it's a tool that is used to call up the SRE. So what you can see is you can see let's see, I'm not that, we don't actually use this. I don't use this tool so much. So what I can see is who is on call when. And I will just zoom in on today. So what you can see is, okay, so until midnight or until this morning, the shift changed just in the morning. So whoever's on call in the night stays on call all night, and then someone else takes over. So Archie has been on call all day, but if I kind of like zoom in here, you can see that Mehmet is on call between 6:45 and 7, because I timed this. Yes, I'm good at timing. So Mehmet is on call over there right now, and we'll hope a real production incident doesn't happen right now. Yeah. Okay. So before I create the incident, let me just see there's some kind of like some escalation procedure here. So first of all, Mehmet is on call. And if he doesn't pick up his phone within 3 minutes, it's calling him again. And if he doesn't pick it up within another 5 minutes, all the SREs gets a call. There's one on parental leave and one who we have a new SRE starting in December. We haven't put him into rotation yet. And I have my head of director of SRE who's coming back from Microsoft this February. So he quit and now he's coming back. That's always a good thing when people are coming back. So it's a fairly stretched thing team. Anyway, if they don't pick up after 18 minutes, I get a notification. Never happened. So I'm good. Cool. So that's how this thing works. So how does we then create an incident? Well, obviously, if there's any threshold CPU memory things alert, things that are happening on production, it will just automatically create. I'm not that. I haven't orchestrated it that well. But so what I want to do instead is I want to go to our engineering channel on Slack, and as you can see here, I just made a message. I don't want to disclose whatever it is. So not too. You don't see everything here. Anyway, anyone in Templafy can and have been taught to create an incident. So you just click on this one, the plus, and then you say incident. Create incident. And this thing, by the way, I haven't rehearsed because, so I hope the demo guards are with us. So I'll say demo for. And okay, so we have two products. We have Templafy One and Hive. Hive is our microservice architecture with the Kubernetes thing, the one I'm demonstrating here. One is our legacy monolith that we are still kind of like hosting. Yes, we did kind of do a rewrite, different discussion for another day. But I'm going to create an incident on Hive here. And what happens is that if we listen carefully in a few seconds, there should be an alert. Here you go. So my SRE who's on call, Mehmet, he's getting an alert and he's picking it up. What happens also is that, I'll just expand these, is that there's an incident channel created on Slack. So what you can see here is that, first of all, it made a bridge, a Zoom bridge. So let me just join Zoom. Okay, so now I'm joining Zoom because I created the incident and I'll just turn my video on here. I'm not sure here. So, there's Mehmet. Hey, Mehmet. Thank you for joining. This is just a demo. It's not a real incident, but so I think maybe I'll just minimize you for a second here, and I will go back to this incidents channel on Slack, and maybe you can help me kind of like tell me how to go through this. I will just zoom in a bit here. Okay, so. Cool. So as you can see, there was an incident created, and the first thing we should do is assign roles. Oh, but okay. So we want to know if this is severity 1, 2. Okay, so this is neglectable. It's just a demo, so this will not count in our stats incident. So okay, cool. So okay, and then the next thing would be to assign roles. So when we have an incident, we kind of want to say, okay, who is responsible for that? And you would be the primary responder, yes? Okay, so you're the SRE on call. Typically, it's the SRE who takes over here and does all this because they do it. They're trained in this. If it's just a random employee, they're like, oh, that's why. Blah, blah, blah. Easy now. Let's just do it by the book and say, okay. So the subject matter expert would typically be someone from the team that released this, and since this was Thiago that did the pull request, he doesn't know. Sorry, Thiago, if you're listening in. And then we have a communication coordinator. If it's a severe thing, we need to inform our business, our partner support, and so on. And that would typically be someone from support. I'll just pick myself now. Okay, so now we kind of like said, this is the team. These are the responsible. We have a wiki that describes exactly what is wrong. So actually, now that we have a bit of time, let's go into the wiki and see what was just released. So I can go to our wiki. I can go to product. I can go to release notes, and I can go to Hive. And since this is a library managed issue, because I heard from the customer, it's probably related to that. Let's see what was actually done. So I said there was some release notes on the work item, if you recall. Okay, so I can't find the work item, but there was these 50 characters. And if I scroll down, I think this was around the 9. Okay, so here it is. this is the release that probably caused an incident. Hopefully it wouldn't take this long to find it. But again, you can see this is a link, and you can see the status of the work item. It's right there, and I can click in and from the release notes here I can do all this thing where I can, all the things I just showed you. But okay, cool. So now you can also see that the entire SRE team was invited to this, just in case that Mehmet didn't pick up. They actually typically help each other. So every time we have an incident, multiple SREs jumps on it because they somehow likes to be an incident call. So I don't know exactly what. Okay, so another interesting thing is that you can see there's a link to DevOps where we have an issue. And I'm just going to open this issue and say, okay, demo for community days, status neglectable, primary responded, Mehmet, Thiago, Thomas. All these things that are filled out is just fed in directly to this incident. And you can see here, when did the incident start? Okay, so I think now actually I'll just do a refresh here because I have this feeling that it doesn't always update. Okay, so somehow this button didn't show up. It is using Azure function, and I'm told it's not that stable. Oh, sorry. It's probably our code. Anyway, I will resolve this incident, and what will happen is when I click here, I can write a summary. Nothing. And detected time, yeah, well, it was detected around here, so I can fill it out. When I click submit here, what's Mehmet down here? This is kind of like you need to know here, because now the incident is going to be closed, and it's actually going to, as far as I know, it's killed the Zoom call. And the SRE team knows, and they're the only one clicking that. But the smart thing here is that this entire Zoom thing, we turned on recording. And if I were to go back to the incident, now Zoom is not that fast, but you can see it actually added a link to the Slack channel. If I were to wait long enough, the Zoom recording would be pasted in here with transcripts, so we can go in and search who said what when, so you don't have to note down who did what. But I will just put the link to the Slack because it needs a link, and then you see the status is now resolved. It's not closed yet because we need to do a postmortem. And the postmortem, we go over here and say we actually have a whole template that on the wiki on what to do. So I'll just fill in some blanks, and then I will click close like this. Yeah, I'm just getting guided because I don't do this. Cool. So now this incident is closed, and in a bit this Zoom recording will be added. And that's about it. I'm on time. I have 1.5 minutes left for questions, and I think Burgers is coming, and there's another stream going on. Second? Yeah, 5 minutes more. 10 minutes more. So now I'm on the kind of like the scary ground, but any questions? Oh, yeah, let's go back to Slack, and I think I have to refresh again because the demo guards is not that stable. But what happened is that didn't happen yet. But when I close the incident, an Azure function should take over and archive this channel. So when I'm actually, yeah. So I can see all the incident that's open, so I can just see it on Slack. If there's a channel that's open with, I know something went on. But yeah, I don't know. Maybe if we refresh again. Any questions from there? I have one over here, and I will repeat it. So keep it short.
For the demo, and special thanks for your naming conventions. They're pretty awesome. My question is: I see you have some customizations in work items in that Azure DevOps processes. How and where do you test them before applying to the real team project?
Okay, so the question is that, as you rightly pointed out, is that we have a lot of customization in work items. Like this is actually an example of work item. We added these attendants and we set this up ourselves. And the question is, how and where do we test it? So what? Actually, not sure if I have any. So okay, so you can make as many Azure organizations, I believe they're called, as you want. So that's what we do. The DevOps team has an organization. So if they do something that's a bit out of the ordinary, they test it there. So this whole incident Bob that we showed was developed in a special environment. We actually have a dedicated Slack engineering thing just for those kind of things, where we can also test the things that we have for the bot. And did that answer your question? Cool. That's another one.
Yeah, the follow-on question: how do you migrate them? Because those processes, they should be like somehow moved, or do you move those in GitOps way?
Okay, okay, good question. How do we migrate these changes from our demo organization to the? And I am afraid this is a manual thing. There's no smart thing, because there's no version control, as far as I know, in DevOps to have these things. I showed you the release pipeline. It does have a history. I can't see who changed what and when, but for the process changes in DevOps, no. So we are quite reliant on DevOps being stable. To be honest, it's probably one of the places where, if DevOps is down, we are quite handicapped. We can, of course, do deployments directly to production, but we don't do that often. We are working on starting to test such things on a regular basis, so we know what to do if those things are down. Other questions? Oh, now there's a lot. I think you were fastest.
How often do you have problems with the DevOps?
How often do we have problems with DevOps? So the deployments themselves. So now I'm looking at my principal engineer, because we, as I said, we want to get rid of this staging environment. But I can just go and this you're trusted, yes. No, this was not the release pipelines. So here you can see the current deployment. So if I go and say all releases, let's see when we can see if. So since December, nothing failed here. I think so. I found this broken one. So there was one. Was that first the 12th of January? There was something that failed in the library management, but in general, so that's why so this would not be a problem, because this is a QA test field. It would not deploy. So not often. But we're trying to take this leap of faith to get rid of the staging environment. There was a question up front, and I'll have you at the end afterwards.
Yeah, what tool do you use for monitoring?
What tools do we use for monitoring? Good question. So we are running Kubernetes, and of course you should use Prometheus, Grafana, and other things. But when we set out to do this, we were on a journey where we kind of introduced hundreds of different principal technologies and so on, and no one was confident with Grafana and Prometheus. So for the monitoring, we are using Azure Monitor. We use Application Insight, we use Container Insight, we use all the things that's under Azure Monitoring, or Log Analytics, I think is the umbrella term. And then we built a lot of dashboards. So every team has their own dashboard that they can configure to their thing. So each team has set that up and are constantly, I hope, updating every time they see. There's always this. You don't want too little incidents or notification, but you also don't want too many, because then you just start ignoring. It's really a balance. So we are quite heavily involved in the Microsoft stack. If it says Microsoft, we're probably using it. We don't use Microsoft for sending mail, because Azure, for some reason, don't have a mail service. I know they have SendGrid, but it's not Azure. Did that answer your question? There's one from back.
Do you do any kind of canary deploys or green blue, or if you do quality assurance with clients?
So the question was if we're doing canary deployments, green blue deployments, and so on. So what we are doing is that we are doing rolling deployments. We don't do canary deployments as in our release pipeline. We do have feature flags that we built into the system. So when we build new feature, we have feature flags. So every new thing is put behind feature flags, and that we can roll out. It's not that advanced. We build it ourselves, but in theory, we could give it to 50% of our customers and test out things. So it's a combination of software. But coming back to the deployment strategy, we have talked a lot about green-blue deployment, where, for those of you who don't really know the difference, green-blue is, if you have 5 servers running version run 1 of a thing, then you deploy the new thing on so 5 servers, then you deploy the new thing on a new 5 new servers, and then you say 1, 2, 3, swap, and then you change all the traffic to this new one. So there's no point in time where you're running both. That's pretty hard with the self-contained system we're doing, because if you recall, every self-contained system has both the web API and background jobs and so on, and coordinating that is going to be a bit of a challenge. So what we do is that we do just a rolling deploy, deploy one here, take one down, and that's what Kubernetes is doing. That also means that all our engineering teams must ensure that the new code must be able to run on the old database without creating any kind of like what's the word I'm looking for? Constraint, integrity problems in the old thing. So we are always trying to take the easy way out. You know, that's also why we don't have these weak wait time until we deploy to the other thing, and we can do trunk-based development, because that means we don't need to have any branching strategies that, you know, with Git flow and feed a branch for every single environment. It's something that we talk a lot about. Some people, you know, when you have a problem, you tend to fall back and that's, oh, then we built this, but then you just introduce a whole new set of problems that eventually will take us slowly back to waterfall. I mean, slowly, there's a long way, but yeah. So, yeah, did that answer your question?
Yes, thanks a lot.
Cool. There's one down here as well.
For the entire incident flow, is it just Azure Functions calling API for like Slack and Zoom, or do you have like something, a third-party system to manage it?
So the question was, for the incident flow I showed, is it just Azure Function, or do we use other third-party or other kind of tools? So I showed you that we have PagerDuty. That's obviously a part of it, because that can send SMS and they can do the scheduling, and it's just a good interface, and it's cheap and good. Very recommended. Go look at PagerDuty. But everything else I showed you, you know, the incident thing in Slack, creating the war room channel and the Zoom thing, it's something we rolled ourselves. I saw it one Monday morning where one of the SREs came and said, see what I built. Okay, that's pretty darn cool. I don't know how much time that was spent on it, but it was not months. And you know, if you're a good software engineer and have access to these things, you can roll such things. We're not going to ship it. I mean, we could build a product and sell it, but now that's a different ballgame. Yeah, we accept there's some flaws. Did that answer your question? Any other questions? There's one in the back here.
The interface between the SRE teams and the dev teams in terms of DevOps, because it could sound like sort of dev versus ops.
Mm-hmm. Yeah, so the question was the interface between, we call them product teams, you call them feature, product teams versus DevOps, because as you rightly point out, is that it seems like we are going back to the old dev versus op thing. So it's a balance. So we use something called team topologies, and when you talk about team topologies, they talk about the different teams. They call them stream-aligned teams. We call them empowered product teams. Different story. And then we have the platform teams. And team topology also talks about different kinds of knowledge. There's the kind of like the intrinsic knowledge. If you're a C# developer, you know how to do an interface on a class. It's just something you do. And then you have, now I can't even remain, but there's all the domain knowledge, you know, what is Templify doing, creating documents, email signatures, and so on, that you need to be really good at. And then there's all the things that, you know, you actually don't want to know. How do you do deployments? How do you do these things? That's why we automated all this out. So to come back to your question, it's not that the software engineering teams cannot write a YAML pipeline or set up all these things. Most of them don't want to, because they are front-end engineers, they are back-end engineers or whatever. They like to do whatever they do. If there is someone on a team that says, oh, I can roll my own pipeline and do, by all means, they do that. The only thing they need is someone from the SRE team to click approve on the pull request. So any software engineer can make the pull request. They just have to have someone from the SRE team to click approve. And that comes back to the thing I set up when I was setting up the stage. We have this enterprise customer. There's a lot of regulations. And they don't trust if I say that 75 engineers can just push things. They like the fact that all these kind of like more fatal things like creating a new Kubernetes cluster, bringing down a database, that there are some people who have this as a special, field and responsibility. So, but also just to, so we started out with something with a Spotify model before we went to team topologies, where we didn't have any platform teams. So the first 2 years when we developed, we started in 2019, going with this thing that I just showed you. The first 2 years, there's no platform teams. It was software engineers building this entire thing. And at some point, it became too much. And there were some people like Mehmet who said he was actually hired as a backend engineer. He's very good at frontend, but he likes that thing as well. So he changed to the DevOps team. So half of the DevOps team or the SRE team are hired as software engineers. And we have a couple that is hired as site reliability engineers. So there's a lot of collaboration, even too much, because collaboration sounds good and but it can also make you slow. You have to separate concerns. So it's a very good question, and I'm like, yeah, it's not real DevOps, but I think the essence of DevOps is that you collaborate. And by having software engineers and the DevOps team that embrace this, and by me telling the operations team that is a site reliability engineer, ship, I don't need to tell them, it's in their blood, it's in their nature, they love it, and so does the software team. So we don't have that problem that caused DevOps to be a thing.
Excellent answer, but also in terms of like metrics, test cases, end-to-end tests, who's responsible for that?
Okay, so the question, what about metrics, end-to-end cases, testing, and who's responsible for that? So back from when we had the Spotify model, Spotify has squads and not teams, and then they have guilds. So we have 7 guilds that has been extremely active. We have a front-end guild, a back-end guild, a cloud guild, a DevOps guild, a quality assurance guild, a security guild, and a tracking guild. Oh, I got them right. So seven guilds. And the DevOps guild it's a Slack channel, and they used to meet every week to discuss things, and it was software engineers going to talking to SREs, and so your question was who's responsible? The guild was, but a guild is not a person. Who is really responsible? Because there needs to be one person. And I'm like, no, you can debate, and you will try to come to consensus. If you have to figure out what to do, I will take the decision. And they don't want me to take the decision, so they always found a way to, take the decision themselves. So that was the last question, because I can see now the burgers are here, and we have another talk that's starting in 15 minutes. So thank you very much. Go grab a beer, a burger, and so on.
Wow. Are we good? You can hear me. Hopefully it's picking up. Okay, great. Hi all, my name is Goran. I work as engineering manager for Pandora. I lead the data infrastructure team. Yes, we are in Azure Cloud. That's my full-time job. My other job over the night or evening is I'm a co-founder of a startup called Synthetic AI Data. If there's some VC with millions here ready to invest, we can have a chat over the beer. Beer is on you if you have millions, right? So who am I actually? I'm a tech guy working in the IT industry for 20 years. I'm enthusiastic about technology. I write blog posts. I like to share my knowledge in different sessions on conferences, holding workshops, and so on. And I got this Microsoft MVP recognition for AI, which also means that I'm focused on that area, but that I also do a lot of things in community, organizing some stuff. And one of the things I'm organizing is Azure Skåne, co-organizer of that group. Skåne is south part of Sweden. So we are organizing meetups over there, usually once a month. So from here, from Copenhagen Central to Malmö Central, you have exactly 36 minutes with train. It goes in rush hour every 10 minutes, usually every 20 minutes, super close. We are organizing this in collaboration with Fucafe in Go to 10 co-working space. I've seen here some faces tonight. Some of you already been there. It's super easy to get there, 150 meters from the train station. You can find us on the Meetup.com. You can find us on LinkedIn. We post some events we are organizing there. Feel free to visit us. It's always in the afternoon if we have one session. If we have some few sessions in a row, then it's on Saturday. Pizza and beer included, as it should be in meetups, right? Of some interesting things coming up, 3rd of March, out of my head now. Saturday, we will have the Global AI Bootcamp organized there with 3 sessions. We still look for speakers. If you have something in that area, feel free to reach out and or just join, meet the community. Everybody's friendly. We like to hang out, have a chat about what we do, sing some ABBA songs. That's a joke, right? So, yeah. And I have this honor to introduce Nikos, who's also coming from that community. I would say at least he held some sessions over there. And he will give an interesting session on Azure Functions.
Yes.
So, stage is yours.
Hello, everybody. Is the sound okay? Great. Thanks a lot for having me. I am very, very honored for being here. I love communities, and today I will talk to you about Azure Functions. This presentation is called How to Lead an Orchestra of Azure Functions, and it's not a clickbait. Well, I'm not going to play the instruments, but it will look like an orchestra at some point. A few words about myself. My name is Nikos Telis. I work as a senior cloud engineer and cloud evangelist at Halo, which is a company in Sweden, and we identify ourselves as a concept and business studio. We build digital products and help our clients to digitalize their workflows. I have a few certifications, mostly or only about Azure. I do love Azure, and I work a lot with it. I am blogging. My blog is called ndteknik.com. I do a podcast called Azure Triumphs, stories of people who succeed with Azure. You may find it in Spotify and Apple Podcasts and Google Podcasts. And I try to be active in communities such as Azure's Corner. It's the second time of me being in Copenhagen for this community. I really like them. I like to share my knowledge and I like to get knowledge. I believe it's really a great experience attending and speaking at community events. More closely about what we're going to talk about today. I wasn't fully aware about the level of seniority of the audience. I see that I have pretty senior people in the audience. I still try to cover a wide area of Azure functions, starting from a serverless computing, of course, with a central view in the Azure functions. I will try to cover when and why we should use them, how to create and deploy. I'll try to maybe do a demo or so. I will also mention a few of the Azure services that are directly integrated with Azure functions and why this is very, very important for us and how it makes our life much easier. I will speak about durable functions, which is one of my favorite topics, but they are a pain in the ass, if I'm completely honest. You have to do many things right, otherwise they can destroy your deployment completely. And then I will try to mention some best practices and some pitfalls that we should avoid. And of course, there will be some time for Q&A. Just one more note before really starting the presentation. We just attended the Muhammad Ali of presentations. Really hot off, sir. One of the best I have ever seen, and congratulations to the whole team. You have built an amazing product. I really like it. I will do my best to keep up. Okay. Well, starting from the very, very, very basic serverless computing. I know that all of you here know the term, and I know that all of you here do it, and I know that most of you worked and built software in the age where we didn't have it. I myself, I have been working for a little more than 10 years as a professional software developer and architect, and I remember the times when we have to zip the www.net folder to back it up, and then FTP, the files up there, to IIS. Those were good times, mostly. Now with serverless computer, it's the cloud service provider that manages the service for us. And I know you know it, but I think that most people don't realize that not having a server, of course, it removes all the need for the server configuration, and you have to have some expertise to set it up and to ask it to do it what you want. And what Azure does, and most of the other cloud service providers, is that they make a friendly interface which enables us to configure the server without getting into INI files and without installing stuff and without breaking the whole internet. So this is a great thing. But it also means that a lot of the configuration is done for us without us. So this is both a very good thing, but we have to keep in mind that we don't control everything. We control what we are allowed to control, and in most cases, it's enough. Scalability and distribution is maybe one of the most important reasons why one should adopt serverless computing, because you cannot just go and buy some servers and then get them leave them back when you don't need them anymore. That's why we have the cloud. So when our needs change, our resources change. And this is also okay, it's a good thing, it's a fantastic thing, but sometimes we have to control how things scale and how things get distributed. I will just name the first in, first out pattern, and I will also name the scalability and distribution of Azure functions. So if we try to apply this pattern and we set the create, and delete, and we expect at first the object will be created and then it will be deleted, and suddenly Azure has had enough, and they have scaled up and scaled out and given us 2 Azure functions. What happens? The first might get the create, and the second might get the delete. And you see the problem there. So again, it's a fantastic thing. We should control it. Fast lane to production. Yeah, like I started saying that I used to zip the www.net folder. I don't do it anymore. And there are, as Thomas saw, they do 30 deploys per day. It is like one of the strongest points. And you can save a lot of money because you don't need to buy this infrastructure. You just buy what you use. Yet again, sometimes things might derail and the costs might skyrocket. So it's good that we have many tools to monitor our costs and to limit our budget so that we don't have difficult moments. Now getting into Azure Functions. Well, first of all, Azure Functions is Azure's take on serverless computing. So we use them to create small pieces of code which execute a task. They get triggered by something, they do something, and that's it, the end. So we do not have to deploy a whole application. We don't have to install anything. We just write our code. We specify when and how our code will be executed, and we're good to go, deploy. The Azure Functions are multilingual. We can write in C#, F#, JavaScript, Java, Python, I believe even Go or Rust, some of those very modern languages, and even TypeScript, and yeah, a few more. This is one of the strongest points and one of the differentiators between Azure Functions and app services. We don't have app services are not that multilingual. I will speak more about the differences between those. Then we have the triggers and input and output bindings. I believe this is something that many people might confuse a little bit. What is the trigger and what is the input binding and what is the output binding? I will show you later in the demo exactly how those things looks like, but in general, the trigger is the event that makes the Azure function fire. The input binding is the data that the function is going to take with it. So it could be a blob, it could be a file from Cosmos DB, it could be a row from SQL, it could be something from the service bus or the event grid, it could be anything. And the output binding, it's much simpler. It is what the Azure function is going to spit out when completing its job. And that could also be a number of things. It could be blobs. It could be various types of data. It could also be again pretty much the same as the input bindings. Pretty much everything. The Azure functions are, of course, integrated with many Azure resources. And this is important not only for the low-code. I don't know how many of you have experience with low-code resources. Logic apps, Power Apps. Yeah, okay. Most of you, actually. Nice. So you know that we can do some pretty basic things with low-code. And when the hits the fan, then we call the Azure function to really do things with code, more advanced things. Yeah, like isn't it like that? I believe it is. And I think it's a very nice thing. I also like the fact that I can pick messages from Service Bus with an Azure function. And I don't know how many of you have done it, but in the Azure function, there is an autocomplete attribute, which you can set to false. And this means that if your Azure function fails to process the message, then the message in the service bus is not marked as processed, as completed, resolved. Yeah, something like that. And this is a good thing because you can try again and again and again, and then it goes to the dead letter queue. And you only need a few clicks to make this work. You don't need to write any logic. You don't need to code this explicitly. The Azure functions are designed to create microservices. They are, I will speak more about that later again, but they are not made to be the whole system. They are made to be small parts, they are called functions. So they should be functions, and they should be deterministic. Deterministic means that for the same input, I get the same output. So they should be created to do one specific part of a job, and only that. They shouldn't assume anything, they shouldn't trust anybody, and they should check everything. Like, validate all input and do not speak to things you assume exist. And of course, we have the durable functions, which are a whole separate session of this presentation. But more or less, the durable functions exist to implement the stateless, serverless stateless pattern. You can do long-running stuff with Azure functions using durable functions. Now, what's the catch? Yeah, there's always a catch, isn't there? Well, first of all, we have a timeout. I checked yesterday, and apparently the timeout is now 10 minutes or 5 minutes for the consumption tier, and then 10 minutes, but as a default for premium and dedicated, and it can be configured to indefinite. It can be like endless. Now, does this mean that the function can run forever? In theory, yes, but we need to keep in mind that if we have the HTTP trigger, then there is a limit of 230 seconds for the Azure load balancer. So no matter what we wait for, if 230 seconds have gone, then we get an error that the request could not be completed in time. Maybe the Azure function is still running, but we won't be able to get the result out of it. Of course, for longer processing of functions, we should use durable functions. I mentioned earlier the trap with scaling and the first in, first out pattern, except from the fact that scaling is going to mean that we use more, so we pay more, and we should control how it happens. It also means that those deterministic small tasks are going to pick up tasks randomly, and we cannot expect any type of affinity. We have the cold starts, both for the in-process and the isolated functions. We have a bottom layer, the host, which is the let's call it application upon which the functions run, and it tends to put our functions to sleep when we do use them. And this is good because we don't want to pay for them. But this also means that if they go to sleep, then we have to wait a few seconds before it wakes up. And there are a few workarounds. We can use a scheduled keep alive function, which runs every 2 minutes, and it just logs still alive, so that the whole function doesn't go to sleep. But this is something that we have to keep in mind. Debugging is also quite difficult, especially if we deploy the functions containerized. I haven't been able to do it, to be honest, to debug directly from Visual Studio to a deployed containerized Azure function. It's a hard thing to do. Then we also have the issue that the runtime versions can be end-of-lifed. They can be dead and buried, like 3.1 .NET Core. Of course, Microsoft tells us in a good time so that we upgrade. But it also means that our applications will be deprecated if we don't upgrade them fast enough. And once again, they can really cost a lot if we use them uncontrollably. And if we use Azure functions for long-running tasks, we shouldn't. If we do have those, then we should pick something else. I'm getting farther with when and why. I pretty much covered this already. Deterministic and stateless tasks, as I said, black boxes. I know nothing. I only know what I have to do and what I will do, and nothing else. I don't assume that anybody will continue after me or that anybody was before me. Then we have the event-driven computing. The whole thing with the functions is that they are triggered by something. So if we are creating an application that is event-based, then of course Azure Functions is the go-to alternative. Microservices, absolutely. Azure functions are designed for it. If we have to use languages, if we're migrated, I get that question a lot. How do we migrate existing applications? Well, if you have a node application that does some stuff, then absolutely, get it in a function. If you have a JavaScript application, yeah, sure, get it in a function. You don't have to stick with C#. You should, because it's the best, but other languages work as well. And why not and when not? As I said, if you have long-running applications, then you shouldn't do Azure functions. And if you have heavy duty with a lot of CPU is Copenhagen. Sorry. So if you need a lot of processing power and a lot of memory, then maybe you should look in other alternatives, because Azure functions are serverless, which means that we have neighbors in the server we live. We can use the dedicated part, but those are really expensive. And then yet again, if you have heavy-duty tasks, then you shouldn't be thinking about functions. You shouldn't be thinking about bigger things, app services or Kubernetes or even VMs, like which we don't use anymore, but they still exist. And if you have advanced features like SSL or TLS, and if you have custom domains, if you want to have a real application, then maybe you should look at other alternatives, because Azure functions are best used as parts of your architecture, not as the whole application. One thing that is usually not very, very easy. It's easy to comprehend, but it's not very easy to implement, are the isolated and the in-process functions. And the difference between those two is that the isolated functions live their own life. They don't depend on the host. They can even run on different runtimes, while the in-process functions share the same memory and the same state as their siblings. So all the in-process functions that are under the same host, they live in the same room, actually. And the isolated, they have their own rooms. And of course, the isolated are available in premium plan, and the in-process are available in consumption and premium plan. Which you should use and when. For me, it depends again on your needs. If for some reason you have the need for isolation and extra security, and you don't want to share memory with the other functions, then sure, go with isolated. If you just want to get going fast and you have low-scale applications, the in-process are just good enough. And in my opinion, since the triggers are a bit different, and the configuration is also a bit different, because in the in-process functions, you get a lot of stuff from the host. You get all the dependencies injections from there. You get it pretty much everything comes from the host. They're easier to program, in my experience, while the isolated, they need a bit more attention. Okay, now it's time to show you how we can create and deploy. I have Visual Studio here, which I cannot seem to, there it is. So I will have to move it here. So we're looking on the same screen. Is it big enough, or should I try to increase it a bit? Let's take 120. Is it readable? Okay. So here I already have this .NET 6 in-process function, nothing very fancy. Now I will bring again the triggers. You see, the first thing I have to declare in my function is the trigger it has and the binding it has. So I have an HTTP trigger which has no security whatsoever. It could have function or host. And I have which HTTP verbs are available and no routes, of course. And I take the whole request with me. And I also get a logger. And this is pretty much the default code that Visual Studio gives us when we create an Azure function. And on there, I have another Azure function which gets triggered by a blob, which means that When we create a blob inside the container called mine container / something, and I get the connection string from here, from here, there it is. Now I use development storage, is the local emulator in my computer. Then what will happen is that I will print this message that this drop called whatever, and of this size was just created. Now let's go on and run this thing. Sorry, I have to move windows again. It shouldn't be that bad. It's thinking. So now I got the first, as you see, I have my both functions here. I can take that one and I will try to run it. I will put it here. And let's see if I can move that window as well. Very good. Now it says pretty much nothing. It says that the HTTP triggered function created successfully. Pass a name in the query string. So if we just name, let's put Nico. I can write my name, Nikos. Yeah. Then says hello, Nikos, and again, that's not like rocket science. I will show you the code that did that. And first of all, the first thing that happened is that we wrote a log message, and you can see it here in the logs. That we're now executing this function, and the C# HTTP trigger function has processed the request. Hello was the first request because I had no query string, and this is like here, hello name, no name, so no nothing. And then when I did put a name, I got a name here. And again, of course, this is not a production level function, but you get the gist of it. You see how it works. And then we have the blob trigger, and for this I will have to bring up the Azure Storage Explorer. I'll just prepare it here. Let's see which screen it lands on. Just a moment. Put it here. Okay, this works fine as well. So we have the blob containers, and we have one called my container. And here I can upload a file. Is this file? Yes, it is. And yeah, let's find the file. Let's find this one. And what happened here again? No rocket science. We just execute this little piece of code. The function was triggered because we had a blob trigger, which was looking at the Azure Web Storage link, which contains my emulator, and then it was looking on this container. And as soon as the file was uploaded there, I got the file with me, and I know it because I read its length, and I got its name, and I printed its name, and I also had the logger injection, so I could print the log message. So yeah, that's pretty much all of it. Now, let's see how we can deploy these nice things. And once again, this has nothing to do with what you saw earlier from Thomas. Thomas, I don't think you're going to like this, but I have to show it. I have my my little resource script here, and I will create an Azure function. Let's see. create a function app. I shouldn't be doing it in the same, let's call it name conventions as always. CPH, this time you get it right. And a few numbers, code, of course, runtime stack, it's .NET, what else? Yes, and let's take West Europe, Holland, Windows, fine, yes, I like it. Review and create, and then I can pick some hosting options, so the storage account in which the Azure function code will be saved, and a few other things. And then I can pick networking and monitoring. And don't worry, I will not deploy this thing. And after that, we have the deployment, and we have some. You see, they have started to put GitHub in this wizard so that we can do automated deploys already from GitHub. Not from Azure DevOps, unfortunately. But no, I know that we can do all kinds of stuff from Azure DevOps as well. And tags, which we should always put, and I will put none. And then review and create to create it. I will not be doing that, as I said. So I will just go back to the existing function that I have. And for me, now I think as a developer, and a rather lazy one, the fastest way to deploy an application is to download the publish profile. And the publish profile is a JSON file, containing information such as the secret key, which I will not show you because I'm not sure if this session is being recorded. And who knows what people are going to deploy in these few minutes. But I have the file already, I think. And I will do a deploy via Visual Studio, which you should never, ever, ever do. But again, this is the fastest way, in my humble opinion, to deploy an Azure function. And here I already have actually a profile, but I will show you how what it looks like when you create one. And I can pick Azure, and then it will ask me, okay, which subscription. And in my account, by mine I mean the account that I am logged in Visual Studio with, I have like 5 subscriptions, so I will not pick this alternative. Instead, I will import a profile. Somewhere here should be the next button. Let's see. This window got enormous for some reason. It should be really, really small. Okay, let's move there next. And then I have to pick the file as the one I just show you. Let's take that one. And I will just like finish, and that's it. So if I push publish, then this big thing will go up to the cloud. I won't do it because it takes a couple of minutes to do it. And there's really no reason, like we do very basic stuff here. I will show you the better way. Like let's write a comment. And let's commit this comment with a command called comment. And commit everything and push. And then, yep, that looks good. I should have somewhere here my GitHub account. Let's see. GitHub. I don't know what this just come back. And I really can see where I am. Okay, I'm here. Virtual Azure, there we go. And I have published this repository to GitHub earlier, and I have a small little workflow, which, yeah, like it's a mini version of automated deploy. So the moment I push something in the master, which you should never do without a pull request, I get some properties from I have some environment properties, and I get the published profile from the secrets page, from the secrets part, which is inside settings and secrets and variables. So actions, exactly. And there I have my published profile. which is the same file I showed you earlier. I have just uploaded the contents of it to GitHub. And what happens is that we have an action that is mostly working, as you can see. And now it's building and deploying, and this thing is going to take 5 minutes, which to me is it's a lot of time. It shouldn't take that much time to deploy a simple function. But yeah, it will. And if all goes correct, which it will, I hope, then we will get our functions in Azure. And I have them already here, actually. This is the one I saw you earlier. And I can take its function URL and the same function. I will just go to monitoring here to show you how we can see the log messages inside the Azure function, connected to application insights, which I had selected when I created the function, but you can also do it afterwards by taking the instrumentation key and putting it in the application in the Azure functions settings. I am now connected, so I can just run the function. And again, if I use the correct, I don't really see now. Where is that? There it is. Name. Then it works fine. I would say that you can try it by scanning that, but okay, I think it's pretty simple. I can publish the repository later if anybody wants to try it. Oh, you will? Okay, interesting. Don't forget to put your name after the question mark in the query string. And now if we do all that, then as you can see, we get log messages right here. It's pretty cool. And of course, not only here, we get the log messages even in application insights, which I have right here. And there is a small delay. I'm not sure if this is because I'm in consumption layer or if this is a general thing, but I have seen that it can take up to 2 minutes for logs to appear. Okay, more people have seen that. Okay, from the function in the application insights. Okay. Now let's get back to our presentation. I'll just pick that here. Okay. So I see time is flying, so I'm going to speed up a little bit. Integration with other services. I already talked about the triggers and the input bindings and the output bindings. And here I have the messaging platforms, Event Grid, Event Hub, Azure Service Bus. I don't know if you all know the differences between those three. The main one is that Event Hub and Event Grid are push and pull message brokers, while the Service Bus, the Event Grid is push all the way. So the Event Grid sees that the action is executed, while the other ones put a message and then the subscribers need to pick the message. We have Azure SQL and Cosmos DB, which Azure functions can be triggered and to implement important bindings of and from and to. We have the Logic Apps and the Azure Data Factory, which also can be hooked up to Azure functions or be triggered by Azure functions. And of course, we have the central parts, the Azure Storage, the Key Vault, and the Application Insights, which also are directly integrated to Azure functions. And now we have to talk about the durable functions. The durable functions are an extension of the Azure functions. So in practice, when we create Azure functions, we just create a usual function, but we use different triggers. So we have the orchestrations, the orchestrator function, which is only one, and the activity functions, which normally are plenty. Because if we don't have plenty, then maybe we don't really have much use of the durable functions. And then we have the secure state management, which the orchestrator does. The orchestrator is a function like all the others, which is executed all the time, again and again and again. and it saves the states of everything, the state of everything that is happening. So when it gets executed again the second time, then it redoes everything. So we have to be very, very careful about what we do in the orchestrator. Example-wise, if we log things in our orchestrator function, then if we don't create a safe logger, we will see the same log messages appearing again. So the first log will say, this is my first try. The second round of running will say, this is my first time, this is my second time. The third turn will say, this is my first, my second, my third time. So we get all the messages from the very, very first until the last again and again and again. And as you can understand, the log messages are expanding exponentially. And this is going to kill even application insights at a point, not to mention how much it's going to cost or the performance issues it's going to cause. Yeah, of course, they are Azure functions, so they're integrated with everything. Actually, we use usual functions with the usual triggers to start, and then we trigger the orchestrator, which in each turn triggers the activity functions. They are used to implement the serverless stateful pattern, as I mentioned earlier, and they have a special trigger called a durable orchestration trigger to get the things going. I have taken this directly from documentation. I know that all people have seen, or most people have seen it. I'm just going to go through very, very fast some patterns that durable functions are very, very well suitable for. We have the function chaining, so if we have functions that should be executed directly one after the other, then durable functions are a very good scenario for that. The fan out, fan in, so we have a lot of data coming in and we want to execute a lot of stuff and wait for all of them to complete. And when they are, then we do something else. This is the fan out, fan in patterns. And in this case, those are all activity functions. We have the asynchronous HTTP API pattern, where, again, we start with an orchestrator, fire and forget, we do an activity function, and we have another one who is looking for the status of that second one. We have implemented that pattern. A couple of years ago, I had a client, a public transport company, which wanted to create and deploy many tickets like for buses and trains and stuff like that. So there was another microservice who created those tickets. So the first activity function asked the microservice, can you please create 10,000 tickets for me? And that's a lot, because to create a ticket, you need to create it's like an official document, kind of, almost. And it has to be documented, and it has to be checked and double checked and then sent to somebody. So it's quite a lot. And we had another activity function which every minute, if I remember correctly, was checking, are we there yet? Are we there yet? Are we there yet? And this is where I first met the unsafe logger, where we asked like 10,000 times and we got millions of log messages. Then we have the monitor pattern, where the activity function can wait for itself to finish. And the human interaction, where obviously a human must trigger event to make the activities go further and continue. And we have the aggregator, which is very interesting because we can use durable functions to implement scenarios when we need to aggregate stuff, like if we have sensors, if we have, I don't know, any type of data which only makes sense as a sum, as a collection, then we can use this pattern to cover everything and then do one calculation upon all the results. I have another quick demo here. Don't worry, it won't be that bloody. I will just, where is my, there it is. I'll just go and create another project here. And I will show you the first two patterns, a new project. Let's take that. And I will do durable functions, take some random stuff because I have quite a lot there. And next, and then I will pick yes.NET 6 runtime support, Durable Functions Orchestrator, everything is correct. I create the project, and here it is. So what we can see here is that we got actually not one, not two, but three functions. We have, first of all, the one that starts everything. This is a usual function which has an HTTP trigger and a durable client. So this is the one that will be our entrance to the orchestration. Then, as you can see, what it does is that it gets an instance ID by calling the starter to start the new synchronous orchestration by calling function 1, which function 1 is the one with the orchestration trigger. So this one is our orchestrator. And this specific one applies function chaining because it will execute first this, then that. And those are all activity functions. And we know that because we can see the activity trigger down here. So if I do execute that, debug, start a new instance. Let's see where the command prompt goes. It went here. Did I pick the wrong one?
It's just old like that.
It's just old like that. Okay, yeah, thanks. Okay, let's take that one. And let's put it here. So let's get things started. Now what I got was the instance ID. And let's see what it says here. So it executed the functions one by one, the activity functions, first Tokyo, then Seattle, then London. So this is the function chaining pattern. And I can very, 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 very easily change that to the fun out, fun in by, let's make a list of tasks, and let's call this thing tasks. Very good. And then tasks add. And I will put that one here. Yep. Now let's repeat it. Let's take that one to 1, and that 2, and this 3. And let's comment out all these. And now let's run a wait task when all tasks. And what this will do now is that it will take those 3 functions and it will await all of them simultaneously. So we will see it. We will see things happening almost in the same time. And I think I can prove it by executing this a couple of times. Let's see what I will do now too. Let's move this thing here, and I can put that here very well. Okay, I think we're good to go. I did right, of course. I get another port. Thanks. Let's take that one. Better now, right?
Right, just found out the wrong question.
Again?
No.
Why?
This time.
Oh. Let's run. Yeah. You're very correct. Thanks a lot. Let's take. Okay. Sorry. It should be up. And of course it went here. So let's drag it here again. No, once more. Come on, thanks. And here we go. And now we'll take the correct URL. And let's put it here. Let's see what happens. Okay, so I got 213. See? Although I wrote 1, 2, 3, I got 213. And if I execute once again, then 1, 3, 2, and again 1, 2, 3, and again 1, 2, 1. What? Oh, 3, 2, 1. So that would be weird. Yeah. Okay. Yeah, but as you can see, this is the fan-out fan-in pattern when we cannot expect that the functions will be executed one after the other. Okay, let's continue with the presentation. I believe that's my last slide. And best practices and pitfalls. And again, these are from my own experiences with Azure Functions, the problems that I had, the challenges that I had, and the things that I have found out to work best. So first of all, the security. Azure Functions are vulnerable. So if we have them completely open, which we can, then they can suffer unauthorized access, data breaches, the DDoS attacks, and we have to mitigate that by hiding them behind more secure resources like API management, or behind balancers, or behind everything else that can do the security for us. And as I said, the function has to be dumb. It has to be very, very, very plain and simple, and only do its work, nothing else. The testing is a challenging thing to test, because most often, and if we're talking about unit tests and automated testing, and we have event-driven functions, then how are we going to do it? Are we going to deploy a service bus and send messages just to test that it works? You can do it, but it's quite a lot of work. So what I recommend in this case is that you isolate the part of the function that really does the work, and that you test that instead. Because the trigger, you can test it once or twice or thrice, but you can trust that the trigger will work, or handle the scenario where the trigger, the input binding is empty, or that something was wrong there, but the function itself, the content of the function, you can test it separately. About the cold starts, again, you can, if you are on the premium tier, you can use the always on feature. Then you don't have the cold starts. If you're not, then you can use this little cheat with a timer trigger when it runs every minute, and it keeps the host alive. Network and data latency, again, serverless equals shared infrastructure. It can happen. The problem is that we don't handle it correctly when it happens. So you should be aware of timeouts that might happen. If you call a function, then get ready, send a cancellation token, and see what happens if it doesn't respond, and be ready for delays, because delays might occur. They are easy to misuse. Yet again, they are so robust and so fast to deploy, but suddenly the application starts to turn bigger, and you do more and more and more, and then it's not a function anymore. It's a whole application, it's a whole API by itself. So we have to remain humble with the function and keep using them for what they're meant to. Last but not least, the auto-scaling. It is based on the number of incoming requests. If you're using Kubernetes, then there are modules who can do smarter scaling, like Keda. I don't know how many of you have heard of it. This is used for custom scaling. So if you are getting orders or something, if you're shipping something, then you can see how many incoming orders you have, and create as many pods and containers as you need in Kubernetes. You cannot do that stuff with functions. And I believe I'm a little bit over time, but that was the last one. So thanks a lot, and I'm happy to answer questions if you have any. Yes?
So I have 50 functions in C#.
Yeah.
How many function apps should I have?
50 functions? Yeah. You can just have one. Am I wrong?
So you would in the same function?
What do you mean by should? It depends a lot on the domain. You need to give me a little bit more information. What are they doing?
They are old-fashioned .NET 4.8 calling CRM system. So they are triggered by service bus.
Okay.
And then they will do something
okay.
with the CRM.
In what tier do you have, in what plan? On the consumption or the premium?
That's another question. I saw you noticed that the .NET isolated should be on
that one. Yeah.
Where? I think we are running it in consumption, but
Okay, I might be wrong about that, and the isolated might be available in consumption as well. But it feels weird to go with isolated. In my opinion, at least, it feels weird to go with isolated in the consumption where the performance is not as good as in premium, and you have less memory and all that. And then isolated means that they all live in separate rooms. I don't know if it works for you. Then totally fine. Absolutely do it. Did that answer your question?
Yeah.
Okay. Any other? Yeah.
So you showed that you have the blob trigger.
Yeah.
And I assume that registers something in the blob store with the event grid. But how is that when you deploy the function that trigger is registered, or how does that work?
The trigger. Yeah. Okay.
You upload a file.
Absolutely. Yes.
Something triggered. But
Yes.
must register something on the.
Exactly. Yeah. Well, the function needs to know where it should listen. So if that's your question, then the storage.
Okay, so the function listens, but it's not calling like every second or. It
No.
must be the blob storage that
It's calling the function.
Yes.
Yeah.
Event grid.
So it should exist before the function, if that's the question.
My question is that when you deploy the function that register is set up, or how does that work?
I'm not. I have to check that and come back to you. I don't have the answer to that one.
Automatically create the event grid topic or something when you deploy it if you don't do it yourself.
blob triggers are not event grid based. They're doing some log scanning. I think it's polling based on a log. You can also do it through event grid, and that's generally recommended because the log scanning is not as solid as the event grid.
Yeah. Thanks. Any other questions? No? Thanks a lot then. Have a good night.
Before you all leave,